Right, so we'll start with the latest maths paper available. Is 2023 paper. Right, so we'll quickly do it. Some of the question we may have done it in the class, but we will do it again, okay? Because this is the latest exam question paper, your paper will be pretty much somewhat more closer to this, right? So let's take one by one. First, read the question paper. One or more correct answers. That means negative marks are applicable. Okay. Right. So let's take question number one. Which of the following propositions are true? These propositions are true, right? So then it is easy. So so this means false implies false. So false implies false is true according to the truth table. So therefore this is true. If Earth is planet, that is correct, right? Earth is planet, then elephants will fly. And we know that elephants don't fly. So that is like true implies true implies false. According to the truth table, true false is false. And 2 is greater than 3 is false. 2 is a prime number is true. False and true is false. 2 greater than 3 is false. 2 is a prime number is true. False or true is true. N is divisible. Now this is tricky because it's talk about N. N is divisible by 2 and 4 if and only if N is divisible by 8. Is that correct? N is divisible by 2 and 4 if and only if N is divisible by 8. There's no such thing, right? For example, if you take something like 12, not divisible by 8, still it is divisible by 2 and 4. For example, 12 is divisible by 2, 12 is divisible by 4, but it is not divisible by 8. So it looks like this is false for me, right? Because I can see some contradictions. Okay. But I can
So
see,
how
sorry,
does the first one is true?
you mean the eighth.
Yeah, yeah.
Now this says 2 plus 2 is 5. 2 plus 2 is 5 is false. And then it says 2 into 3 is 9. That is false, right? So according to the A imply B logic, right? Truth table is A, B, A implies B. True is true. True, false is false. False, true is true. False is true. So therefore, this is false implies false. False implies false is true. And you can see false implies false is true according to A implies B logic. So that is why we took this as true. Is it clear?
Yes, sir.
Yeah. So therefore, I'll take now the answers are because earlier I was looking for proposition, but now the question is these are propositions. So you need to find whether it's true or false. So therefore, answers are A and D, right? A and D. Yes, A and D. Okay. Right. Second one. If log 10 11 is A, log 10 1 over 110 is equal to. Now log 10 11 is given as A. So the answers are also in A now. Right. So let's write this log 10 1 over 110. So you need to use 11 somewhere now. Maybe 11 into 10. Okay. Because I need to get A to this answer, this expression. I'll write this as log 10. Division is subtraction. Division is subtraction. So therefore, first I will do the division as subtraction. Log 10 1 minus log 10 110. 110 I can write it as 11 into 10. And we know that log 10 1 is 10 to the power 0. Therefore, this is 0, right? Because 1 is 10 to the power 0. So therefore, this is 0 minus. Now we have multiplication. Multiplication means addition. Okay. Addition. That is log 10 11 plus log 10 10. And log 10 11 is A. So therefore, this is minus a plus log 10, 10 is 1 because 10 is 10 to the power 1. Minus a plus 1 or minus 1 plus a. So this is my answer. Minus 1 plus a. It can't be 11a and blah, 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 right? I'll go for D. Yes, answer is D. If you have any questions, you need to ask, right? Otherwise, I will now go faster. Right, so this is another log question. 3 divided by 4 equal minus 1 divided by 2. So this is, right, we'll get rid of log. We'll write it as a, remember, if a equal b to the power c, we can write it as log to the base a, log to the base b, a equals c. From here, you can write this. From here, you can write this. So therefore, this is a logarithmic thing, which I can convert it to a power expression. So then it will be 3 by 4 equal x to the power minus half. 3 by 4 equal x to the power, you can see, a equal b to the power c. Right now it's easy. 3 by 4 equal x to the power minus half is 1 over x to the power half or root x. Now I will cross multiply. 3 root x equal 4. Root x equal 4 by 3. If root x is equal 4 by 3, your x must be square of this. Your x must be 16 divided by 9. Because then only your root x is 4 by 3. Actually, your root x can be plus 4 by 3 or minus 4 by 3. But anyway, possible answer is 16 divided by 9. Right? Can it be any other answer? No, we can't simplify, right? No common factors. Right? A. Yes, 3A. Fourth one. Which of the following statements are true if the domain consists of all real numbers? Right? All real numbers. This says x is x. That means at least one real number where x squared equal minus 1. And you know that none of the real numbers if x squared is minus 1, x is root minus 1. And negative numbers root, can it be a real number? No. Because when you multiply two positive numbers positive, negative numbers negative. So therefore, so this means basically x equal root of minus 1. Right? So root of minus 1, for example, root of 25 means you need to find a number. When you multiply it by itself, you get this. Right? So that means you need to find a number. When you multiply by itself, you get minus 1. But you know that positive into positive is positive, negative into negative is positive. So therefore, no real number that satisfies this, because when real number multiplied by itself, there's no way you can get a negative value. Because if it is a positive number, it's a positive value. Negative number, it's again a positive value because negative into negative is positive. And of course, 0 is 0. So therefore, no real number. But we can find this number, but that is called imaginary number, right? So those who have done A-level maths, they know that we can find this in a different way, but the question is all about real numbers, and in your syllabus, we don't cover imaginary numbers. So therefore, there's no real number for this kind of a situation. So basically, for negative square roots, right, any number, minus 5 or whatever, you can't have a real number solution. So therefore, there's nothing like this, right? Not at least one. Okay, so therefore I'll say uh, this is false. Right? It says for all x, 3x is greater than 2x. Now these questions take time, so just keep these questions and do it last, right? Because you need to look at a lot of scenarios. Okay, lot of scenarios. Right, what about this? I'll keep this last because it's the old one. What about this? Do we have at least one x where x to the power 4 is less than x to the power 2? At least one x, if you find, you are done. Right? Do we have something like that? say 2 to the power 4 is less than 2 to the power 2?
No.
Not for any positive uh, numbers bigger than 1. Then what about negative numbers? No, not because when you take the square root, square and fourth power, negative numbers are also becoming positive numbers. But I'm interested to see whether are there fractions also, like say 1/10. This is 1/10 to the power 4. Is it less than 1/10 because it's talk about real numbers? 1/10 to the power 2, right? Uh, is that correct? This is 1 to the power 10, 1 over 10 to the power 4. 1 over 10 to the power 2. This is 1 over 1000. This is 100. So that is correct, right? Because 1 over 10 or 0.1 is a real number. So that for me, it looks like for fractions or proper fractions, this is correct. This is correct, right? Because 0.1 fourth power is less than 0.1 second power. So therefore, I'll take this. Okay. Is it clear? Right. So then what about this? Of course, when x is 1, 1 to the power 2 is same as 1 to the power 3. Already I found a number. Right? What about 0? 0 to the power 2 is equal to 0 to the power 3. This is correct. Right? Right. Now we are into that other possibilities. Right. Now I have got at least 2 answers. That means I collect some marks. That is why I asked you to do it last. Right? Right. So then what about this? All x. 3x must be greater than. Now again, for bigger than 1, it is correct, right? 3 times 10 is bigger than 2 times 10. Then look at negative numbers, then look at fractions. Okay. And also positive fractions, negative fractions separately. Right. So this is correct for positive numbers bigger than 1, negative numbers bigger than 1. Because uh, if x is minus 2, say 3 into minus 2, is it bigger than 2 into minus 2? 3 into minus 2 is minus 6, minus 4. That is also false, right? Minus 6 is not bigger than minus 4. So something like even negative numbers, this doesn't work, right? This doesn't work because it says all x real numbers. For example, when I say minus 2, 3 into minus 2 is minus 6. It is not greater than minus 4. Minus 6 is lesser. It's in the left side. So therefore, this is not correct. Right? So if it is all x, see whether there are contradictions. If you find at least one contradiction, you are done. And of course, when x is 0, also 0 is not greater than 0, right? So those are the good values to check for contradictions. Because if you can find at least one contradiction, that's the end of the story. Right? What about this? I'll look at 0 first. 0 squared, yeah, this is 0 is 0. Then I will look at this is minus x squared is anyway x squared, right? Looks like okay, right? But let's take something like 2 minus 2 square. Is it equal to 2 square? Yes, right? For positive number, so say that my number is this is my number is 2. Now my number is minus 2. Minus 2 squared. Is it minus 2 squared? Yes, right? So 0 it works, positive numbers it works, negative numbers, fractions also it should work. Because when you square, negative doesn't matter. I'll go for that. I'll go for that. Because I can't see any contradiction. Because limited time, I can't check all the contradiction, but possible things are 0, numbers, positive numbers bigger than 1, negative numbers smaller than 1, positive numbers between 0 to 1, negative numbers between 0 to 1. Those are the possible ranges you can check. Right, I will go for C, D, and E. Yes, C, D, and E. Those are true. Right. Question number 5. Actually, I'm also doing this paper for the first time because this is the last year paper. So this is the first because last year paper is first doing with you guys. Okay. That is why I just took it because I also like to take some challenges. So what about this? 3 to the power a plus b is 243. 3 to the power a minus b is 27. So can you write, if this is a power of 3, you know that a to the power x is b to the power y means, sorry, a to the power y means x equal y. When base same, power must be same. Other thing is x to the power a equal x to the power b when base, sorry, uh, other way. A to the power p equal b to the power p when power same, base must be the same. When base is same, power must be same. When power is same, powers are same, base must be same. Right? So therefore, if I can take this to the power of 3, then I can write an equation. If I can write this is power of 3 equation, 2 equations is enough to find A and B. I think 27 is obviously a power of 3. What about 243? Is it power of 3? If it is power of 3, we are done. Right, 3, 9, 27, 27 into 3, 81, right, 81 into 3, 240, yes, 243. That is 3 to the power 1, 2, 3, 4, 5. So that means 3 to the power a plus b equal 3 to the power 5. That means base is same means powers must be same. A plus b equal 5. Second one is obvious. 3 to the power a minus b is 27 means 3 to the power 3. So that means a minus b is 3. Right, now you need to find a and b. But you need to find a. So 1 plus 2, 2a equal 8, a equal 4. Right, a equal 4. Answer is D. D. හරි එක්සෑම් එක වෙලාව තියෙනවා නම් ඒත් බලලා ඒත් හොයලා මේකට දාලා සුළු කරලා බලන්න උත්තරේ හරිද කියලා. වෙලා තියෙනවා නම්. Right? Just to double check. මොකද සුළු කරද්දී වැරද්ද වෙන බලන්න. But that is if you have time. Question 6. Let P and Q two propositions. Which of the following is a tautology or tautologies? So this is time consuming. Right? Exam එකේ අන්තිමට කරන්න යා. මොකද truth table එක අඳින්න තු බලන්න බෑ. This is doable, time consuming. අපි මේක අන්තිමට කරමුද? මාක් කරලා යන්න. ඔක් කරන්න ගත්තම නිදිමත හැදෙනවා. ඒ truth table අඳින්න එපා. කරනවා අන්තිමට. Right, what about this? Let P be the statement product is good. Product is good. Q be the statement service is good. Symbolic form of the compound statement either product is good. Right, so I think they have taken this as P and Q, right? So let's take this P, take this Q. Symbolic form of the compound statement either product is good, that is P, or service is good, or service is good, but not both. That means either means or. You don't need either, just or. But not means and. Remember, but means and in logic, right? But is the same as and. That means and, not both. That means not P and Q. P and Q. Okay. Either product or is good or service is good, and not both. And but means not. And but means not in logic. And this is straight away says both means and, not both. Or you can say not P, but not both. Is it not P and Q or not P and not Q? No, right? Not P and Q. Not P and Q. So therefore, I'll go for this. Do we have something like that? POQ and not. First one is like that. What about second one?
So is that sign not sign?
Sorry?
Is that sign
Yeah, this
like
is
L
yeah,
inverted?
this is another sign for not. So this is another sign for not, right? Either you can use this sign or this sign. Yes, it's another sign for not. Or you can logic digital circuit we use even dash or C. Right. So this is another sign for not. Right. So right. I don't think that this can be simplified into any other thing. So therefore I'll go for A. Okay. Yes, 7 is A. So it's just put it into a symbols, okay? Right. Product is good or service is good, but means and, not both. Not both. Right. Which of the following statement is a propositions? Propositions. Give me a glass of water. This is not a proposition. This is a request. Request, wishes, right? Those are not propositions. Propositions means something you make a statement. Like this is a glass of water. Right? This is give me a glass of water. The only even prime number is 2. Yes, only even prime number is true. There's no other even prime number, right? So it's true proposition. What is time now? Questions are not propositions. We discussed that, right? Questions, wishes. If x and y are odd integers, right? If x and y are odd integers, then x plus y is an odd integer, right? So remember when you add two odd numbers, like 3 and 5, what you get is even number. That is correct for any odd number, right? Say 7 and 13, you get 20, right? 5 and 9, you get 40. When you add two odd numbers, you always get even number. So this says if x and y are odd integers, then x plus y is odd integer. No, x plus y is an even integer. So therefore, this is always false. Always false, right? Though we have xy, the statement is always false. Not sometimes true, sometimes false. If some statement is always true, it's a proposition. If a statement is always false, it is a proposition. So therefore, I'll go for this. I'll go for this as a proposition, false proposition. Wishes are not right. Wishes are not good morning, God bless you. Those are not propositions. So I'll go for B and D. B and D. B and D. Okay. Is it clear? Right. Ninth one. The inverse and contrapositive of conditional statement P implies Q are respectively equal to. So we discuss about those contrapositive and inverse, but I can't remember the exact word we use, right? So definitely we discuss about that. Of course, you need to remember those. Okay, let me open the note because I have forgotten what is exactly inverse, what is exactly contrapositive. Okay, definitely we did this. I don't know whether we use the exact word. Yeah, inverse, converse, and contrapositive. So this is the statement x implies y. Remember, x implies y means either x has not happened or y has happened. Okay, definitely. Either y must have happened. If not, x must not have happened. Because whenever x happens, y happens. Right? Whenever x happens, y happens. So therefore, either y has happened or x has not happened. Okay. Right. So then what is the inverse? Sorry, this is a contrapositive. This is converse. This is inverse. Right. So contrapositive means not x implies not y. Sorry, not y implies not x. Converse is y implies x. Inverse is not x implies not y. Right? Out of these, which one is correct? positive V is correct, but converse and inverse are not correct. Right? Only contrapositive V is correct. What is contrapositive? When X implies Y, right? Whenever X happens, Y happens. Okay. So therefore, if Y has not happened, X has not happened. Okay. Is it clear? Whenever X happens, Y happens. Okay. Whenever X happens, Y happens. Right? So that means if Y has not happened, that means X has not happened. That is correct. That is contrapositive is correct. But converse and inverse are not correct. You can't get into that kind of conclusions. Okay. Right. So therefore, what is the answer? Um, Right. First, they ask inverse. Inverse is not X implies not Y. That is not P implies not Q. Right. Not P implies not Q. Right. Those are the inverse. Then the contrapositive. Contrapositive is the only correct one. That is not Y implies not X. In this case, not Q implies not P. Right. Not Q implies not P. Right. This one, right? Not Q implies not P. So therefore, answer is E. Ninth one, E. Answer is C. Okay. So remember, this is correct, but this is not correct, right? There is a common misunderstanding of people when they are not very sure about logic. තනිකර මේ මිනිස්සු ගේම ගහන්නේ මේකෙන් හරි. ඔයගොල්ලෝ දන්නවා ජීවත් වෙනවා කියන්නේ මොකද්ද? ජීවත් වෙනවා කියන්නේ වැඩ දෙකයි කරන්නේ මිනිස්සු. හරි? වෙලාවකට අපි හරි වැඩ කරනවා. තව වෙලාවකට අපි මිනිස්සුන් අන්දනවා. ඔච්චරයි කරන්නේ. ජීවත් වෙනවා කියලා සමහරු වැඩි හරියක් කරන්නේ අන්දන එක බොරු කරන එක. සමහරු වැඩි හරියක් කරන්නේ හරි දේ කරන එක. සමහරු ඉතා කලාතුරකින් තමයි මිනිස්සුන් අන්දන්නේ බොරු කරන්නේ. 99%ක් ජීවිතේ ජීවත් වෙනවා. තව කට්ටිය ඉන්නවා 99%ක් බොරු කියන්නේ අන්දනවා 100%ක් විතර ජීවත් වෙනවා. Taman තීරණය කරනවා මොන පැත්තටද යන්නේ කියලා. ඕකට තමයි ඔයගලන්ට කියන්නේ. හරි. හැබැයි අපේ ජීවිතේ හැමදාමත් 100%ක් ඇත්ත කියන්නත් බැරි වෙනවා. 100%ක් හරි බොරු කියන්න වෙනවා. හැබැයි ඒක අඩු කරගන්න එක තමයි අපිට තියෙන දක්ෂකම. ඒක තීරණයක්. It's a decision. ඒක තීරණයක්. සමහර මිනිස්සු ඉන්නවා නිකන් බොරු කියන්න අවශ්‍යතාවයක් නැත්නම් වලත් බොරු කියනවා. ඒ කියන්නේ ඒකට ඇබ්බැහි වෙලා. ඒකට ඇබ්බැහි වෙලා. එහෙමයි වුණ තරම් ලංකාවේ වැඩි හරියක් ඉන්නේ බොරු කියන කට්ටිය තමයි ආ. බොරු කියන කට්ටිය ජීවිතේ රඟපාන කට්ටිය. ඒකන බොහොම පරිස්සමෙන් ජීවත් වෙන්න හොඳේ. විශේෂයෙන් ලංකාවේ මිනිස්සුත් එක්ක. බටහිර රටවල් වලට යනකොට මේ මිනිස්සු ගොඩක් අය බොරු කියන ප්‍රමාණය අඩු කරනවා, සෑහෙන අඩු කරනවා. මේ මිනිස්සු ජීවත් වෙනවා. Right? Right. 10th question. Life is a choice. Right. ඔයගොල්ලෝ කවදාවත් කල්පනා කරලා බලන්න ඔයාගේ ජීවිතේ කොච්චර බොරුව 100ට කීයද? ඇත්ත 100ට කීයද කියලා. හරි? Right. Let Cx be the predicate or propositional function. X is a comedian. X කියන්නේ විකටයෙක්ලු. Right. So that is Cx. And let Fx be the predicate. X is funny. So that is by Fx. Then the statement, every comedian is funny, can be symbolically written as every comedian is a funny. That means whenever comedian Cx, it implies funny. But now we need to add every comedian. Whenever someone is comedian, he is funny. Comedian implies funny. But now you need to put something called every comedian. Is it all here? Because not exists, right? Every, so therefore I'll exist answers I will get rid of. So now I have only two answers, right? So this can't be the case. This means comedian and funny, right? Comedian and funny, but it's also indirectly correct, but this is more related, right? For all legs, comedian implies funny. Comedian implies funny. Okay, comedian implies funny. But what about this? All are comedians and funny. All are comedians and funny is wrong, right? හැමෝම comedians නෙමෙයි. මේක විදියට හැමෝම විකටයෝයි විහිළු සහගත කට්ටියයි වෙනවලු. ෆනි කියන්නේ හරි සතුටින් ඉන්නවා කියන්නේ. හැමෝම එහෙමයි කියලා නෙමෙයි මේ කියන්නේ. කොමඩියන් කෙනෙක් ඉන්නවා නම් මිනිහා ෆනි. නේද? ඔයගොල්ලෝ ඒක තේරෙනව නේද? ජනයි ප්‍රියයි කියවම ෆනි. චූටි මල්ලි පොඩි මල්ලි කියවම ඒගොල්ලෝ කමඩියන්ස්ලා. ඒගොල්ලෝ ෆනි. හැබැයි සීරියස් මිනිස්සුත් ඉන්නවා නේද? සීරියස් මිනිස්සුත් ඉන්නවා. So therefore I will not go for this. මේකෙන් කියන්නේ හැමෝම comedians like funny අය කියලා නෑ. ලෝකේ එහෙම හැමෝම comedians like funny අය නෙමෙයි ඉන්නේ. හැබැයි comedians like එන funny. I'll go for it. Yes, answer is A. Anyway, these are nothing to do with because this says some 11. Let A equal 1, 2, 3, 4, 5. I forget to add A delta B to your note. Right? So just I will add that to the note also. ඔයාලේ note එකේ මට මේ operator එක දාන්න බැන්න මීට කලිනුත් ඇහුවා ඔබ. මට මතක විදිහට අවුරුදු දෙකකට කලින් වගේ. Right. So remember we discussed about A intersection B, A union B, A minus B and B minus A, and also A complement. Right. Those are the things we discuss, and also we discuss A XOR B, though it is not official thing. Right. So then what is A delta B? මොනනිත් එක. මොකද note එකේ නෑ වගේ. So this is belong to both. Right. So this is either belong to A or B. Okay. This is A minus B means belong to A but not belong to B. Say this is A, this is B, belong but don't belong to B. And what is A XOR B? A XOR B means exclusively belong to A or exclusively belong to B. It's different from union because union has the middle part. So then A delta B is, right, A delta B is, A delta B is another name for XOR. Sorry. A delta B is another name for XOR. That means exclusively belong to A or exclusively belong to B. Actually, we did it, but we use the symbol XOR, right? Word XOR rather than delta. So delta is the symbol for XOR. Sorry for that. Okay. Delta is the symbol for XOR. So therefore, basically what they're asking is, we did XOR, but we didn't use the symbol. So delta is the symbol for XOR. So therefore, what is this? That means you need to take exclusively belong to A parts, exclusively belong to B part, but not common things. Right. So let's eliminate the common things. 5 is common. 2 is common. 3 is common. Right. Now I have eliminated the common things. So therefore I need this part and this part. That is 1, 4, 6, 7. 1, 4, 6, 7. Answer is C. At 11C. Right. 11C. C. So අපේ note එකේ අපිට උත්තර delta කියලා දාලා තියුණා ඒක අවුල් වුණේ හරි. Sets. Sets. මේක දාන්න නැත්නම් අමතක වෙනවා. හැමදාම අමතක වෙනවක දාන්න මට. Right. So another symbol for XOR is delta. Delta. Unicode. You see delta. Because that is the symbol they use. This is somewhat new symbol they try to familiarize in maths of not UCSC, right? In mathematics. Right, now it's done. Okay. Otherwise, I always forget this. Right. So now we'll move on to the 12th question. So basically, delta is the symbol for XO. Okay. Because we don't use XO as the name for sets rather than we use it for logic, right? Just like AND or XO. So therefore, sets, they have introduced a new symbol, delta. Right. Which one of the following is not a predicate? Predicate means a propositional function, right? So there's a difference between proposition and predicate. Proposition is always either true or it is always false. It may have variables, but definitely you can say it's true. Definitely you can say it's false. Predicate is a propositional function. That means it's a statement with variable, and depending on the value of variable, it can be true, it can be false, right? But again, it can't be something like questions, commands, wishes, and so on, right? Right. So what about this? X squared plus 2x equals 0. Is it always 0, or depending on the value of x, it can be true or false? For example, when x is 0, this is true. But for any other number, this is false, right? Any other number like 1 squared plus 1 squared is 1 plus 2, 2 plus 1 is 3. 3 is not 0. So that means it has variable. Yes. That means it has it is a function, and also it can be true or false, not definitely true or definitely false. So therefore, this is a propositional function. That means sometimes true, sometimes false, depending on the value of x. This definitely sometimes true, sometimes false. For example, 5 is greater than or equal to -1. But if you say -10 is greater than or equal to -2 is false. So it can be true, it can be false, and that there's a variable. It's a propositional function, right? This is easy one. X is a cat. Yes, if X is Nimal, false. If X is the cat, some cat of some house, this is true. So depending on whether it's a cat, it's a true. But if you look at a lion and say dog and say X is a cat, that is false. So it can be true, it can be false, depending on the object you are looking at. Propositional function. So X loves Y. So that is interesting one, right? So say actually Nimal loves Amali. So then it is true. But actually Nimal does not love Nimali. So then it is false. So therefore, depending on these variables, this can be true, this can be false. Right? This can be true, this can be false. Of course, I know that the word love is not a very formal word, but if you take it in the general sense, because sometimes we love others, sometimes we don't love them, we don't care them. Okay, I'll say propositional function. What about this? Now, this is a tricky one, right? Because this is true for any x value, any real number, any real number. Say x equals 0, 0 minus 1 is -1, 0 minus 1 is -1 into +1 is -1. Say x equal 10, because this is a general algebraic rule. So algebraic rules are always correct. That is why it's a rule. For any real number, this is correct. So that means for any real number, this is true. If something is always true, for all the values it is true, it is not a predicate, it is a proposition. So therefore, this is a proposition. This is a proposition. This is not a predicate. So for me, predicates are A, B, D, E. Right? A, B, D, E. Or not a predicate. Sorry. Right. The question is not a predicate. So what is not a predicate? Because this is a proposition, the not a predicate is C. Right. Sorry. The question is all about the reverse. Okay. Not a predicate. So because these are predicate, C is the not a predicate because it's a proposition. Okay. Right. Sorry for that. Answer is correct. Right. Next one. Let P, Q, and R be three propositions. What is the negation of the propositions P implies Q or R? අපි එකත් අන්තිමට කරුම් පොඩ්ඩක් ඔළුවට සමනල ගැටේ වැටෙන ඔක් කරන්න ගියොත් දැන් Right, next one. In a group of 100 students who appeared for an examination, 32 students failed mathematics. 52 students failed physics and 24 students failed in both mathematics and physics. What is the total number of students who passed both physics and mathematics? Set studying karo. In a group of 100 students, so here we have 100, who appeared for an examination, 32 students failed maths. Fail. So this is maths. This is physics. Okay. And 24 students failed both mathematics and physics. So that means 24 is here. Fail both maths and physics. Okay. What is the total numbers who passed in both physics and mathematics? Right. Now this is 32 students failed in mathematics. 32 students failed in mathematics. Many method LE not is 32. Right. So outside this we have 32. And here we have 29. Right. Now outside this means this part plus this part. Do you agree? So outside N we have 52 because 52 students fail, 32 students fail mathematics. So fail mathematics means outside this. Outside this means this part plus this part. When you add this, you get the outside maths. Okay. So that is 32. But here we know that 24 is there. So then this must be 32 minus 24, right? 32 minus 24. 8. So therefore I'll go for 8 here. Is it correct? My logic one manusen. Right. So then if this is 8, this is 29. Now what is the question? Right. Question is how many students are here? Right. What is the total number of students who pass both physics and maths? Now this is 8. Do we have any other information? This is 100. In a group of 100 students who appeared for the examination, 32 students failed. Now, can we assume that all 100 students face either maths or physics? කියලා තියෙන දේ නැහැ එහෙම කරන්න බෑ නේද? බෑ නේද? දෙක fail වෙච්ච ඇති නේද? In a group of 100 students who appeared for an examination, 32 students failed in mathematics. 52 students failed in physics. මේ 52 students කියන එක පාවිච්චි කරේ නැහැ නේද? Right. අපි 32 පාවිච්චි කරා, 24 පාවිච්චි කරා, 52 පාවිච්චි කරේ නැහැ. 52 students failed in physics. 52 students failed in physics. That means outside this, there are 52 students. Right? Outside this, there are 52 students. That means this part and outside. Okay, so therefore, this part must be 52 minus 24. 52 minus 24 because this part plus this plus is 52. So that means 2 minus 4 is 12, 24. Yeah, 24. 12 minus 4 is 8. Then 4 minus 2 is 28. Okay, so then this must be 28. මම වැරද්දොත් කියන්න 28. Now the question is how many here? Right. Now we know that this is 24. Right, this is 24 and altogether 100. So therefore in the union we must have 100 minus 24. බලන්න ලේසි විදියක් තියෙනවද කියලා මට අහුවෙච්ච විදිය තමයි මම මේ කරගෙන යන්නේ. So in this union you must have 100 minus 24. 100 minus 24. 6 minus 10 minus 4 is 6. 9 minus 2 is 7. 76. Okay. So here 76. Already we have 28 and 8. So the rest must be here. 28 plus 8 is 16, 36. Right, 36. But altogether it must be 76. So therefore rest of the guys must be here. 76 minus 36. 40.
So we can take both the sets as those who fail mathematics and those who fail physics, and then do like that also, no?
Okay, first let me double check the answer. 14. Yes, 14 answer is correct. Right. What is your way of doing it? Okay, just let me draw it again. Uh, let me draw it again. Because there can be an easier way. I also thinking like there should be easier way also. Anyway, I got the answer. Right. What is your logic? I can draw. This is maths. This is
Yeah, those who fail maths and those who fail
you consider
physics.
this as those who fail maths rather than pass.
Yes,
I think
yes,
that will be easier. Yeah, I think that will be easier. Right. So let's do like that also. I think that will be easier. Right. So this is maths. This is those who fail maths. Other one is those who fail physics. Right. So then still my universal set is 100, right? 32 student fail maths. So that means here 32. 52 student fail physics. That means here 52. In this set, okay? In this set. 24 student fail both maths and physics. I think that is easy, right? What is the total number of students who passed in both physics and maths? Both physics and maths. Now, how can we proceed? Now, this is 32 minus 24. 8. This is 52 minus 24.
28.
28. Now, that means we can find this also. That is 52 plus 8. That is 60. This is 40, right? This is 40. Right now, what is the question? What is the total number of students who pass in both physics and mathematics? So that means they must not fail maths and also not fail physics, right? If a student has not failed maths and not failed physics, that means that student has passed both maths and physics. So that is this one. So the answer is 40. Is that your way of doing?
Yes, sir.
Yeah, I think that is easier, right? That is easier. Anyway, it's a good that we have now two approaches, right? Because usually when you draw sets, we usually look at the positive things. That is why I went with the positive things. But it looks like if you look at the negative aspect and draw it, right? I think yes, definitely it is faster to get the answer. But you must be very careful, especially getting the final answer, right? So the final answer is what is the total number of students who pass both physics and maths? But here we have the failures. So therefore, this is not fail maths or not fail physics. Not fail maths or not fail physics is those who pass both. So therefore, getting the final answer is tricky. You must be really logical thinker to get the final answer from this. But in previous approach, getting the final answer is correct, easy. But building the Venn diagram was little bit difficult because they talk about the failures, but we are keep looking for the past students. Okay. Right. Anyway, both approach we get the same answer. Right. 15th. Let A 2, 3, 4 and B blah blah blah. Which of the following statement is true? Right. So this is X is a real number. This is 0. That means this has a solution. Right. This has a solution. Maybe one solution, two solution, or no solution. But about this, b squared minus 4ac, a is 1, B is minus 7, C is 12. And 4 and 3, right? No, not 4 and 3. Okay, let's double check. B squared. That is minus 7 squared minus 4 times AC. Minus 7 squared is 49 minus 48, right? That is 1. Square root of 1 is bigger than 0, greater than or 0. Therefore, we have two solutions. Two solutions. What are those two solutions? නිකමට හොයන්නේ මං 7x ධන 12. What are the solutions? Minus 4 and minus 3? Yes. X squared minus 4x minus 3x plus 12. Then x minus 4 into x minus 3, right? Yeah, two solutions are there. Right. Now the question. Anyway, let's look at the answers because maybe they are interested in answers, right? So therefore, let's simplify this. If I take x out, x minus 4. If I take minus 3 out, x minus 4 equals 0. X minus 4 is common into x minus 3 is 0. X equal 3 or x equal 4. So those are the solutions for this. Because here we have 3 and 4. Okay. Right. Which of the following statement is true? Now A is 2, 3, 4. B is 3, 4. That is why I solved this. 3, 4. Another way of writing this is B is 3, 4. Okay. Right. Which of the following statement is true? A equal B? No. A is a subset of B? No. A is a proper subset of B? No. B is a proper subset of A? Correct. Because B is inside A and not equal. A intersection B is not A. Right? A intersection B is B. Right. Answer is D.
So what is the proper subset?
Proper subset means, say, when we have something like this, we can say that A is a subset of B. A is a subset of B. Now, that means every element in A is element in B. This is correct where even when A equal B, because every element in A is in B. So that is why we use this symbol. But if you eliminate this possibility, that means every element in A must be in B, but A is not equal to B. So then we say A is a proper subset of B. So that means every element in A is equal to B, but there is no possibility of A equal B. So then it's a proper subset. So here you can say it's a proper subset because every element in B is in A, but B is not equal to A. So whenever you say B is a proper subset of A, you can say that B is a subset of A. That means this implies this, but it doesn't mean this implies this. No, this doesn't imply this, but this implies this. Is it clear?
Yes, sir.
Right. Right, next question. So if you get an A for this subject, I'm really proud of you. I'm really proud of you because this is your best subject. Best subject for check whether you are a logical thinker. That is the most important thing in your life. Right? Not memorizing this and that and other thing. Okay. Right. So therefore try to get an A plus for this. Right? A plus for this. If you can go get A plus for this subject, right? So that is I really happy about you guys. Right? Not for any other subject. This subject. Okay. Right. So let A, B, and C be three subsets of a set. Then A minus B union C is equal to. Now remember A, B, and C be three subset of a set. Let's say that set is our universal set. Okay. A minus B union C. Let's draw it as a general thing. A, B, C. From A, you want to remove B union C elements. So then when you remove B union C element from A, what you get is this. That is basically exclusively belong to A. Right? Exclusively belong to A. right? Now what about this? A minus B union A minus B means belong to A but not belong to B. Right? Let's draw this. It's time consuming, but let's do it. This is what we are interested. Okay. Right. So let's take this. Just draw it big. Okay. I have a small screen. Make sure it's in the same order, right? මෙතන A, B, C දාලා මෙතන මාරු කරන්න බෑ. Belong to A and not belong to B. That is this. Union belong to A and not belong to C. Belong to A but not belong to C. That is this. And we take the union. When you take the union, you get something like this. But that is not this. So this is not answer. This means A minus B. Okay, let's draw it again. A, B, C. A minus B. From A, you want to get rid of B. From A, you want to get rid of B. That means this part. From that, you want to get rid of C. So that means this part you need to get rid of. So then what you get is this. Yes, that is what we are interested. Right? That is what we are interested. So that is correct. What about the C? A minus B. Belong to A but not belong to B. That one. Intersection A minus C. From A, you want to get rid of C. Right? Get rid of C. That is this. Then you need to take intersection. So intersection is only here. That is correct, right? Intersection is here. So therefore, this is also correct. දැන් ඒ වගේ අනිත් එකත් බලන්න. right? අනිත් දෙක check කරන්න. So B and C are answers, but D and E check කරේ නැහැ. හරි? 16th. Oh, B is not answer. C හරි. No, B is not answer. Why is that? Right. අනිත් දෙක උත්තර නෙමෙයිලු. Let's see why B is not answer. Let's do it again. ටිකක් ලොකුවට අඳින්න වෙනවා. හරි? මට මේ ස්ක්‍රීන් එක පොඩි හඳ නැහැ මේක අඳ ගන්නවා. A, B, C. A minus B. From A, you get rid of B. So then you have this. From that, you get rid of C. මට නම් ඒක හරි වගේ. When you get rid of C, what you get is this part, right? What you get is this part. And this is also the same, right? B union C අයින් කරා. For me anyway, B and C both correct. අපි ChatGPT එකෙන් අහලා බලමු. Siri අයගෙන් අහලා බලනවා වගේ. Because examiner says only C, but for me B and C both are correct. Anyone? ChatGPT එකට කලින් ඕගොල්ලොන්ට මට කියන්න පුළුවන්ද මම වැරදිද කියලා? I like to get it from you guys. Maybe I'm wrong, right? මොකද්ද මගේ වෙච්ච වැරද්ද? බලමු. Let's see ChatGPT's opinion also. ChatGPT also says only B is correct, right? ChatGPT කියන්නේ B විතරක් හරි කියලා මාර සීන් යන්නේ දැන්. ChatGPT is not interested in C. Now we are in great trouble. Because examiner says C, ChatGPT says B. Right? I think ChatGPT thinks that only one correct answer. Right? I'll give a hint to the ChatGPT. Multiple answers are correct. සමහරට කිව්වට පස්සේ ඕ කියලා එන්නත් ඉඩ තියෙනවා. හරි. දෙපාර වෙනම එකක් කියනවා. ChatGPT පිස්සු ඇදලාද? Okay, forget about that. අපි පොඩ්ඩක් ඒක ඕපන් තියමුවා. මම හිතන්නේ නම් දෙකක් හරි කියලා. ChatGPT පිස්සු ඇදලා ඒක බලන්න. Right. It's very rare that ChatGPT make a mess of that. Right, next one. Question number 17. Let A 1, 2, 3, 4, 5, 6, 7, 8, then the number of subsets A containing either 2 elements or 3 elements is. That is more like combinations and permutation, right? Number of subsets of A containing either 2 elements, these are unique elements, or 3 elements is. So how many ways you can, not how many ways, right? Because, yeah, how many ways we can pick 2 out of this, right? So that is 1, 2, 3, 4, 5, 6, 7, 8, 8C2, right? So that we can pick is not arrangement, pick, because order is not important. Either 2 elements or 3 elements. So then 8C3, right? 8C3. How many ways we can pick 3 from 8? So 8C2 is factorial 8 divided by factorial 6, 8 minus 2 divided by factorial 2. And this is addition, right? Not multiplication, because how many ways this way or that way? Here factorial 8, factorial 8 minus 3 is 5, and factorial 3. Is that correct? Factorial equation. Open karu note එක මට මතක නැහැ. Correct, right? Right. Correct, na correct. So then, factorial 8 divided by factorial 6 is 8 into 7 divided by 2 plus 8 into 7 into 6 divided by 3 into 2. So this is 4. That is 28. 8 into 7 into 6, right? 3 into 2. 3 into 2 is 6. Then 8 into 7. 56, right? 8 plus C, 14. 84. 84 possibilities. Is it the answer? 17. Yes, answer is C. Right. So how many ways you can pick 2 out of this? Plus how many ways you can pick 3 out of this? Okay. So now remember we discussed about what is known as power set. But power set is 2 to the power how many elements? 1, 2, 3, 4, 5, 6, 7, 8. That is total number of subsets. 2 to the power 8. That is 2, 4, 8, 16, 32, 64, and so on, right? That is bigger than this. But this is just 2 set of subsets from that. Right, question 18. Let X and Y, these 2 sets, then the number of proper subset X union Y is equal to. Right. First, let's calculate X union Y. Let X this, Y this, then the number of proper subset of X union Y. First, let's find X union Y. 1, 2, 3, 4, 1, 2, 3, 4, 2, 4 is already there. 6, 8. Right. How many subsets we have? That is a power set. How many subsets we have? That is a power set. That is 2 to the power number of elements. 1, 2, 3, 4, 5, 6. 2 to the power 6. Okay. So that is 2, 4, 8, 16, 32, 64, right? 64. But this includes the set itself, because set itself is a subset. But this is not number of subsets of this. Number of subsets of this is 2 to the power 6, right? That we discussed, right? We call that power set of a set. But this is number of proper subsets. So therefore, we need to eliminate one from this because one of that subset is itself. So therefore, 64 minus 1, 63. Answer is D. Answer is D. Okay. Right. 19.
So do we subtract one?
When we take power set, the definition of power set says take all the subsets. Right. For any sets, the set itself is also a subset. Because subset is something like this, right? I told you when we say subset, the set itself is also there. But when it comes to proper subset, this equality is not there. So therefore, you can't take the set itself as a subset. So therefore, you need to eliminate one subset from that. Is it clear? Now it's something like this. Let me open the note. Sets. Right. So this is the definition of power set. Take all the subsets. Set of all possible subsets. Remember, when we take subsets, the set itself is also taken. You can see this is a power set includes the set itself. Because by definition, power set is all the subsets. The subset includes itself. But the question says all possible proper subsets. So therefore, these are all correct. Though these are all proper subsets. But this is, you need to eliminate this because this is itself is not considered as a subset. Okay. Or proper subset. So that is why I have to remove one from this 2 to the power n. Okay. I hope it's correct. It's now clear. Okay. Right. Right. 19th question. What is the cardinality of a set of odd positive integers less than 10? Okay, that is grade 8 students question. Right. How many positive integers are there? Positive integers less than odd positive integers? 1, 3, 5, 7, 9. So therefore cardinality is 1, 2, 3, 4, 5. On that time, take over here. 19C. Right. Question number 20. Right. Let S be set with 5 elements. Then how many binary relations are there on S that are reflexive and symmetric? Okay. SB set of 5 elements. So that means you have 5 elements. say 1, 2, 3, 4, 5. 5 elements. Then how many binary relations? How many binary relations are there on set S that are reflexive and symmetric? Remember, and reflexive and symmetric. How many relations? Right. If it is reflexive, definitely 1 to 1, 2 to 2, 3 to 3, 4 to 4, 4 to 5 to 5 must be there. But I'm a little bit confused about what is this question is. How many relations?
So what is the meaning of reflexive?
Reflexive means it's mapped to itself. We did that, right? It mapped to itself. 1 is mapped to 1, 2 is mapped to 2, 3 is mapped to 3. That is called reflexive. Uh, but this talk about relations, right? Relations. Symmetric. Symmetric means if there's 1 to 2, there must be 2 to 1, right? But how can we calculate? How many? One to 2, there must be 2 to 1. If there's 1 to 3, there must be 3 to 1. But there are so many possibilities, right? Right. By the way, now I think the relations means this kind of a connection here. Usual relation means so like y equal x squared. Okay. But I think here relation means there's a connection like that. But all here we have 1, 2, 3, 4, 5. Then maybe 1 to 2, 1 to 3, 1 to 4, 1 to 5. Then of course all the possibilities will be there, right? All possibilities 1 to 2, 1 to 3, 1 to 4, 1 to 5, then 2 to 1. It's like how many ways we can connect. I don't know. That is my gut feeling. 1, 2, 3, 4, 5. I'm not very sure about
The,
that one.
the is
Yes?
the question about equivalence relations?
Sorry?
Is the question is about equivalence relations?
No, right? It's not talking about equivalence relations, right? It's only talking about how many reflexive and symmetric. Because if it is equivalence, it must be transitive also. I'm not very sure about that. Let's keep that open for the time being. Okay. I'm not very sure about that. Why? What is the answer given? 20. A 2 to the power 10. 5 elements, 2 to the power 10. That is 1024 relations. Okay, we'll keep that open for the time being. Right, 21. Let X and Y be two subsets of the set of a set. Then X intersection X Y union X complement is equal to. So we need to draw this, right? Shade this. We have only X and Y. Let's say this is X, this is Y. Y union X, first it must belong to X. And Y union X complement means everything outside X and Y. Okay. Okay, let's shade it in two different colors, otherwise we get confused. Let's shade it in two different colors. This is X and Y. X intersection, this is my X, and Y, X union Y complement. X union Y complement means anything not belong to X or Y. Anything not belong to X or Y. That is something like this. Right? And its intersection. There's no intersection, right? Because then it must be empty set. Because X union Y complement is this pink area, X is this red area, there is no common area. If there's no common area, it's empty set, right? So answer must be E. Right? Answer must be E. Right? 21 answer is C. Yes, answer is C. 22. Let P and Q be two propositions. Which of the following statement is correct regarding the argument P implies Q, Q, therefore Q? Right. Valid argument. Oh, they have given some names also. I'm not very sure about these names, but we will at least check whether it's a valid argument. Valid argument, valid argument, valid argument. All are valid arguments, but they have given it a name, which we never discussed, right? Anyway, P implies Q, Q, therefore P implies Q, Q, therefore Q. Of course, if Q has happened, right? That's obvious. But the question is, how do you call that? Actually, we never did something like that. Okay. And these are, I don't know what kind of language is this, tolerance, ponens, and blah, blah, blah. Let's see whether we can guess it. I can't guess anything from these two because I have no idea about what this means. Policy of, it says not valid, right? Let's at least, no, this is valid, right? P implies Q. Q has happened. If Q has happened, Q has happened. Right? Anyway, let's double check. So we can assume that these assumptions are true. Right? So if Q is true, Q is true. So therefore, definitely answer can't be invalid. Not a valid can't be answer. Okay? Not a valid cannot be answered. Now at least we have better probability. But I'm not sure which is the correct name for that. But answer must be something with A, B, and E. Okay? 22, what is the answer? Answer is C. How come C? C says not a valid argument. It is not a valid argument. But this is valid, right? P implies Q. Q, therefore Q.
So is that therefore symbol?
This one. This is not
Yeah.
therefore symbol. This is the symbol we used in arguments, right? Conclusion. Right? We did this, right?
Okay.
Conclusion symbol. Logic. This is same as therefore symbol, okay? But this is valid, right? How can we say this is invalid? You can see this is exactly this example. P implies Q. No, not this one. P implies Q, Q therefore Q, right? Yeah. P implies Q, Q therefore Q. So one way is you can argue, otherwise you can prepare the truth table. So whenever all these are correct, if this is correct, true, argument is valid. Okay. So how do you determine whether the argument is valid? Either you can argue with yourself or draw truth table and see if the conclusion of the argument is true whenever all the premises are true. Okay, let's do it like that also. Whenever all the premises are true, if the result is true, maybe because answer says invalid, right? P, Q, P implies Q. True, 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 false, false, true, false, false. This is true, this is false, this is true, this is true. Right. So this is one of the premises. This is the other premises. P implies Q. So whenever both are correct, this must be correct. That is, whenever both are true, this must be true. Then it is valid. Let's see. So both are true, and this is true. And you can see when both are true, this is false. So that means this is not valid. Yes, this is not valid. You can see when both are true, but this is false. No, we say Q, right? Sorry, sorry. So again, I made a mistake. So these are the premises. Your conclusion is also Q, not P. So this is my conclusion. It's really confusing, right? So this is my conclusion. So that means whenever both are true, this must be true. You can see both are true. This is true. Both are true. This is true. So therefore, this is valid. This is valid. Right? Have they given anything here? 22. No, they talk about 39. So 22, I don't agree that it is invalid. Okay. So therefore, I want to ask this from ChatGPT. Definitely. Because in both ways, I get it as valid. Unfortunately, this is in two different pages. I will just ask, is it valid? Okay. That is my first concern. Is this valid argument? For me, this is a valid argument. Yes, you can see this is a valid argument, but the examiner's answer says this is invalid argument. Because the examiner's answer says 22 answer is C. Answer C says it is not a valid argument. So I don't agree with the examiner's answer at all. Okay? I don't know. Right? For me, 22 must be, right? Answer must be valid. So let me mark that also. 22. Sorry, 20. Yeah, 22. I don't agree with this answer. Not only me, ChatGPT also. Okay. Right, so this one. Let me mark that. Right. So next one. So anyway, that is even ChatGPT says it's valid argument, right? At 23, the meaning of the proposition exist x all y p x y in predicate logic is. So that means for some x, for that x all y, this is true. So that means there must be at least one x value, but for that x value, for all y values, this is correct. This is true. Okay. Right now, let's try to read it. There is x is some x, correct, such that pxy is false. No, not false, true. There x is some x such that pxy is true for every y. So that is my answer. For some x value, there's all, and for that x value, one or more, all y values, this is true. For every y, there x is some x such that pxy is false. No. So you start with there exists some x, not every y value. But I think we can write it like this also. For every y, yes, all y. No, I don't think we can swap this. So we need to read it from left to right. Right? I don't take this. Right? This is anyway wrong. I'll go for B. I'll go for B. Yes, answer is B. Okay? Answer is B. So is it clear? That means there's at least one x or some x, but for that x, all y, this is true. Okay? 24. Let P, Q, and R be three propositions. If the compound proposition P implies Q implies R is false, then the truth values of P, Q, are respectively equal to P, Q, R. P implies Q implies R is false. What is that? This must be false. I think because we have the answers, we can check one by one. So the first one is true implies all are true, right? True implies, otherwise we need to create a big truth table. True implies true is true. And true implies true is true. But it says false, so therefore this is not answer. Next one. True, false, true. True implies false implies true. False implies true is when this is false, this is true. Right? That is true implies true. Right? Remember the truth table? False implies true is true. And true implies true is true. But it says false. What about next one? True implies false implies false. False implies false is true. And true implies true is true. Therefore, this is not answer. Next one. False implies false implies false. False implies false is true. Then false implies true is true. Right? When this is false, definitely answer is true. And what about this? True implies false. True implies false is false. That means again true implies false. True implies false is false. So this is false. Answer is C. 24 answer is C. Yes, answer is C. Right, answer is C. Right, 20. I closed the question paper, right? Right, 25. The coin is tossed 10 times. The number of all possible outcomes is, right? Coin is tossed 2 times. So every time there's a possibility of 2. It's something like this. 2, again 2, again 2, again 2, again 2, and so on, right? So how many possibilities are there? Is it 2 to the power 10? Use your common sense. Uh, if it is 1 times, you have 2 possibilities. 2 times, you have 4 possibilities. Right? 2 times means something like this. 1, 2, 3, 4. 3 times, another 2. 1, 2, 3, 4, 5, 6, 7, 8. Now look at the pattern. No, pattern ball. So if it is 10 times, and this is 2 to the power 1, 2 to the power 2, 2 to the power 3, then 2 to the power 10. 2 to the power 10, 10. Answer is A. 25 A. Yes. 26. Let A and B be two subsets of set. Which of the following is are correct? Right. A minus B is belong to A and not belong to B. Correct. Belong to A and not belong to B. A union B is belong to A and no. AO. A union B belong to A or belong to B. This is wrong. This is correct. Answers are A, C, E. 26 AC. Yes. Okay, just give 1 minute. Right, 27. If X and Y are two subsets of a set, then X intersection, okay, we will draw this. Just two sets, X and Y. Y X intersection, I think we had a similar question, right? Belong to X and not belong to X intersection Y. Not belong to X intersection Y. So that is this everything other than intersection. Everything other than intersection. So then we need intersection. So the intersection is this area, right? What is intersection? That means you need both blue and green. This area. That means basically X minus Y. Right? X minus Y. Answer is B. Yes, B. Right. This is a very easy question. 28. Let R1, 1, blah, blah, blah. Let's draw it. Which of the following statement is correct? Reflexive, symmetric, antisymmetric, transitive. Let's draw it like this. 1, 2, 3, 4. 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, 4, 4. 4. 1, 1, 1, 2, 1, 2, 2, 3, 3, 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. 4, 4. Right. Is it reflexive? Yes. Every value has mapped to itself. Is it symmetric? Whenever there's A to B, there's a B to A. Correct. Antisymmetric? Antisymmetric means whenever there's A to B, there's no B to A. Right. The relation cannot be both symmetric and antisymmetric. So therefore, this is wrong. Transitive, when there's A to B and B to C, there must be A to C. Right? For example, there's 1 to 1 and 1 to 2, then there must be 1 to 2. Right? I think it's not violated, right? Whenever, of course, you don't see something like this and this and this, but that property is not violated here. So therefore we can take it, right? Yeah, I don't know whether this is little bit debatable, but this is not violated. I will say yes. Of course, not antisymmetric. I'll go for A, B, and D also. 28. Yeah, D, because it's not violated. A, B, and D. 29. Let R be a binary relation on set of all positive integers defined by n comma m in a R. If and only if n divides m. Okay, so we'll stop at this point because otherwise we will not get chance to do database. But we've skipped few questions. We'll do those. Otherwise we will forget about that. ඒක දැන් මැකුවා නේද මම? කොයි එකද අපි skip කරන් ගියේ? Right, we skip this one, right? Skip this one. And also one more, right? Let's first do this one. Of course, to do this, you need to draw the truth table or else see whether we can argue. Make sure you do these questions at the end if you have time. Of course, you must. දැන් උදේ 8ට පටන් ගත්තා නම් පේපර් එක එකතු කරන්න ඇවිල්ලා. හරි. But anyway, we took breaks also. Right. POQ implies, I don't think this, my gut feeling doesn't say that this is a tautology. Because POQ implies Q means maybe if it is P has happened, that means Q has not happened. Right? So tautology means it's true for any possibility. So this is, මොකද මට truth table අඳින්න කිව්වොත් වෙලා යනවා හරි. POQ implies P and Q. That is also not a tautology for me. මට සැකේවල විතරයි මම truth table අඳින්නේ. Because POQ doesn't imply P and Q, right? P and Q implies POQ. This looks so correct for me. Because when P and Q has happened, right, we can always safely say POQ happened. Because both P and Q has happened. Right? But these two I can't say like that. Therefore, I need to draw the truth table. මේ වෙලාව මදි නම් නැත්නම් ඔක්කොම මේ truth table අඳින්න. Right. P, Q. True, 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 false, false, true, false, false. Then I need P implies Q. True, 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 false, false. True, true. P or P implies Q. This and P O. True or true, true. True or false, true. False or true, true. False or true, true. It's a tautology. It's a tautology. What about this?
So tautology means all the values should be true.
All the output value must be true for all the combinations.
Then if it is all false, also it's not tautology.
Then it is a contradiction.
Okay, sir.
Right. So this next one, P, this is Q implies P. So Q implies P is not P implies Q. So therefore I need to come up with Q implies P now. Q implies P. Now, when we have this left-right method, okay? Q implies P. True, true, true. False, true. True, false, false. False means true. Now, this is Q implies P. This is Q implies P. And this is my P. I need to take O. True or true? True. This is true. This is false or false is false. Therefore, it is not a tautology. Right? It is not a tautology. My gut feeling says these are not tautologies and this is a tautology. හැබැයි වෙලා තියෙනවා මේවත් බලනවා. හරි? But මම එක්සෑම් එක කරනවා කරලා හිතුවොත් මම ගහන්නේ B and E. B and E. Right? So that is 6-1, right? Yes, B and E. Right? But if you have time, always do the truth table. I just halfway some of those I just use my common sense, others I use the formal approach. අපි තමනාට skip කරාද? I think 9th one. These are just right, the contraspective and inverse, right? That you can write.
We did it.
We did that, right? We did that. Which one we skipped?
13.
13. This one. Let P, Q, and R be. Okay, let's copy this. Let P, Q, and R be three propositions. What is the negation of the proposition of this? That is negation. That is not of this, right? Not of POR. Sorry, not of P implies QOR. Negation. Right. Remember we can if we have P implies Q, X implies Y, we can write it as either Y has happened or X has not happened. Remember we can write it like that. Y has happened or X has not happened. Right? That is how you convert this to this. Right? We discussed that. Let me get back to this Boolean logic. Right? You can see X implies Y means Y has happened or X has not happened. Right? Y has happened or X has not happened. Right? Y has happened or X has not happened. So therefore I can write this as, this is my Y, QOR, or not left side not happen, not P. But I need the negation of this, right? So therefore it's negation. So why I wanted to convert this to this? Because here we have a De Morgan rule. Here you don't have a De Morgan rule. So therefore I first converted this into this so that I can do the negation. Okay. Right. Now I can apply the De Morgan rule because this is like X or Y. X or Y not is not X and not Y. So therefore this I can write Q O R not and not of not P. That is De Morgan rule. And not of not P is P. That is not of Q O R and P. Do we have that as answer? Or this I can write not of QOR, not Q and not R. Not Q and not R. De Morgan rule again. Okay. So then and P. And you don't care which one is first. So that means not Q, not R and P. Not Q, not R, P. When we have all ends, we can swap them. We don't care because A and B is same as B and A. So this is an answer for me. This is not an answer. All are not. Here, P is there, but these are O. These are not answers for me. I don't know what is this. Right? I don't think these are answers. So therefore, for me, answer is A. A. Okay. Let's see. What is that question? 13. Yes, answer is A. Did we skip anything else? No, right? I think we did all the others. Yeah, we did, but this one anyway, I'm not very sure. Right, so we came up to 29. How many questions are there? Yeah, we can go for 40, but if we go for that, we will not be able to finish the syllabus for the database today, right? So therefore, we'll do those next time. Right, so now we'll move on to database. Right, database. So we have done up to 28, right? 2023 up to 28. One to 28 done. And you will be having extra sessions from next week, okay? Weekday evening sessions. Because this week also, this week also possibly we can have a session Wednesday or Thursday. Okay, I will let you know whether you have, possibly you have a session Wednesday or Thursday, or we'll see. Because this week the priority is given to the semester 4 student. Now semester 6 semester 6 syllabus is over, but I need to give priority to semester 4 because your exams are in. Right, so let's move on to databases. Okay, shall we take a small break and go into the databases? Just 10 minutes. Right, so then now it is 10:15. We'll start at 10:25. And we'll move on to security and views. First view, then security. Then syllabus is over. Right, so let's start at 10:30. Okay, so let's start. Right, so now we move on to database. Our final topic is data security and views. So views are related to security. Then the syllabus is over. First, we will do the views part. Then we'll move on to the data security. Okay. Right. So you have two separate notes for that. One for views, one for security. Okay. Make sure you go through the UCSC note for all your subjects. Okay. While you go through our notes. Right. So let me open the view note. Right. So what is mean by a view? So far we have been discussing about tables, right? And relationships, relations and relationships. But remember in 3-tier architecture, right? So the relations and relationships and tables or relationships are related to the conceptual layer. Conceptual layer, tables, relationships. And what you have is files, data files, index files. The external view is end users view, managers, operators. So they like to look at it as forms, reports, and so on. So, right? Something which is related to external layer is another thing is called view. So views are something like in between conceptual and external, but usually we take it as external thing. Okay. So what is mean by view? So view is when we bind our forms and reports, we can bind it to tables. That is one way. Another way is on top of tables, we create views and we can bind our forms, reports to views or views and tables depending on the situation. So therefore, view is more higher abstraction of tables or set of tables so that we can easily bind it to a user interface or user functionality. Okay, so that is the idea behind views. And views has some security purpose as well because when we create a view, we can restrict access to that particular table. For example, we can create say we have employee table, but we may create a view which has only employees of marketing department. So that the marketing manager can be given access to marketing employees view. Whereas engineering department manager can be given access to engineering department view rather than the employee table at database level. So therefore, there's security aspect also. Okay. So it make it easier for securing things, and also easier to connect to the UI and other business functionalities. But underneath views, there are actual tables. Okay, if it is not clear, let me know. Okay. Right. So when it comes to views, there are two ways you can implement a view. We call it query modification and view materialization. Right. So query modification means there is no physical table-like things. View is conceptual. It's a SQL statement. And when you refer to the view, actually you are referring to a virtual or logical thing built from your tables and possibly loaded to your memory. But there's no actual view saved in the files, right? So you take only you have the tables.
So
View
it's
is at that time.
so
Sorry,
is it like a abstract?
sorry.
Is it like the abstract thing?
Yeah, it's abstract. It's conceptual thing, not abstract thing. In a way, abstract, but it's conceptual thing. On top of tables. Remember, tables are also conceptual, right? Tables are also conceptual because reality is files. So this is even high level, or we can say it's a little bit higher level abstraction than tables, right? Higher level abstraction than table, mainly because we can give control the security and we can better present it to the other business tier. Right? In query modification, there's no file or something. It's just virtual. But if you go for view materialization, on top of the tables, you create a view, and that view is also like a table. So that means this is also saved as a file. Saved as a file. Right? So that means you need more storage because maybe your employee details are in employee table as well as marketing employee view. Marketing employee view. And some functionalities are related to marketing employee view, some functionalities are related to employee table. But then the data is duplicated because those are saved in files. Very rarely we go for view materialization, but there are situations we go for view materialization for performance reasons. Most of the time we go for query modification, or default is query modification. On the fly at that time, the view is created and loaded to the memory. Okay, but when you go for query modification, you need more memory. Okay, more memory. So there's a question, all conceptual things are abstract. Of course, these are two different ways of looking at things. So in a way, abstract means concept. Okay. But abstract is relative thing. Right? Concept is concept. For example, kindness is a concept. Right? Politics is a concept. There's nothing called, it's more conceptual. Of course, if you want, you can look at that also, but abstract is more relative thing. We can say it is more abstract than the other thing. Okay. But it's two different things, right? Two different things, two different things. So abstract is one thing, concept is another thing. Concept is a general thing. Abstract is sort of a adjective. Okay, sort of an adjective. So that means we can say this is more abstract than the other. Okay, but this is also concept, that is also concept. Okay, right. So this is how you create a view in SQL. Create view, you give a view name and your query. Simple as that. Okay, so let's do it as a practical thing. Right, so we are into the view now. I will share the full code today because today is our last coding session, hopefully. Right, so remember we have already created two tables, our S225 table database, employee table, department table. So employee table has uh, ID, name, salary, and department ID. Okay, ID, name, salary, and department ID. So we are going to create a view on top of employee table, right? So create view, say, okay, let's say this is my department one. What is my department one? Department one is HR. Okay, so that means let's call this HR employee, right? Select all from employee where department ID is one. Department ID one means HR employees, right? HR employees because department ID one is HR. And some of our employees department ID is one. Okay, right. That means our view will have only these two records, Fatum and Mohammed. Okay, right. That is how you do it, right? Let's create. You can give any name here. And if you want just some fields, you can restrict here. And already we have restricted the rows, right? If you want, you can project only required columns also. Right. I have selected my database and go to SQL and create it. Go. Right. Now you can see under tables, we have department and employees. Under views, we have something called HR employee. Now this is like a table, but you can even see the data, but this is virtual, right? This conceptually, this is basically this pump data from employee table. And when we create a view, even you can join two or three tables because this is a select statement. You can join two or three tables and create your view also. But then that big data structure, you can refer to it as another sort of a table. Then you can query from that view. Okay, that is the idea. Right. So now I can write a select statement on view also. Say select. So we have the employee ID and say name and salary from say HR employee. So now we query from the view, just like table. Of course, you can query from table also. Only the HR employees because my query is based on the view and view has restricted to department ID one. It's super simple concept, right? Super simple concept. Is it clear? Right. So when you create your view, you can select only some rows using the where condition. You can select only some columns, and you can do both. Right. So we call them selection views, projection views, and also you can combine tables and create join views. Okay. And also you can create summarized views as well. Like if you use sum, average, so then your view has summary view. Summary view. So then someone will ask, why do you want to create summary view? Maybe we can bind a particular report to that summary view. So then creating a report is easier because report is bound to the view rather than table. But then you need to create the view using, right, having count and so on. Okay, group by, right, and of course we can connect tables and create a view and joining some tables. So then you can query from this table. Then that query is easier to write. Okay. And also you can bind your UI to this kind of a view. Then your UI development is also easy when you work with records. Right. So remember, we can even update a view. For example, uh, I want to change the salary of Mohammed, right, from 350,000 to 400,000. So what can I do? I can write like this. Update salary, sorry, update HR employee. If you want, you can update the table also, but now I'm updating the view. Update HR employee, set salary equal 300,000, where otherwise each and every HR employee salary will be updated. Where, so let's look at the view first so that I can use ID. Where ID equal 3. Okay, ID equal 3. Is it ID or? Yeah, ID equal 3. So it's just like a table now. Okay. Now 350,000, we want to change it to, okay, let's change it to 400,000. Now we update the view. Let's see whether we can update it. Go, right, success. Now let's go to the table view, 400,000. Go to the table, they are also 400,000 because your view is basically looking at the table. In reality, what you have is a table, not the view, because this is not a materialized view. This is a very modified view. Okay. If it is a materialized view, we have separate table, then data is duplicated. Okay. Got it? Right. Now, if you don't want, now something that can happen is when you change your view, sometimes your record can go out of the view. Right. For example, now if I change my now this is my view. If I change the ID, so, sorry, department ID of this employee Pathum, it will go out of the view. Right. For example, let's write it. Update HR employee, set department ID to 2, where ID equal, what is that ID? Muhammad's ID is 3. So, but this update will take this record out of the view. Out of the view. We can do this, but then all of a sudden this record is not in this view. You update this view, but now the record is not in the view because this view is only for department ID 1. Now let's say execute this because we change the department ID to 2. Okay, go. Oh, it says foreign constraint fail. That means possibly there's no department ID 2 in our table. Let's double check. Yes, there's no department ID 2. So therefore, let's change the department ID to maybe 6. That is nothing to do with our SQL sheet. Okay, because it must be a valid department ID. Referential integrity constraint. Right, now let's run it. Done. Right. But now if you go to the HR employee view, that record is not there because this view is only for department ID 1. But still the table record is there. Now this guy is in a different department. Because this guy is in a different department, this guy is not in this view. Now there are situations we need to restrict this because you are not supposed to send your record outside your view. Maybe it can be done by some others having access to the table, like admins and so on. So in that case, when you create your view, you can restrict that. First of all, let me show you how to drop a view because we are going to drop this view and create the view with some restrictions. Okay. And this is how you drop a view, just like drop a table. Drop view. Your view name, HR underscore employee. Go. Now the view is not there. You can see view is not there. Now we are going to create the view. Right, so this is how you drop a view. Drop view HR employee. Now we are going to create the same view, but restricting someone taking the records outside the view. So how to do that? How to do that? That is where we have with check option. With check option. That is additional statement. Okay, so let me add that employee back to the HR department. Otherwise, we have only one record. Okay, I'll change this back to department 1. Right, so that I have 2 records again. Now I'm going to create the view again, but this one is restricted view where you can't do that kind of updates. SQL, go. Okay, so the view is again created, but this time with that restriction. Now 2 records are there. Now let's see whether we can do the update. We are taking that department 1 employees to department. Okay, department 2 is not valid. What are the valid department? Yeah, we change it to department 6 and see what happens now. We change it to department 6, which is valid, but we are doing the update to the HR employee view. But now that when we create the view, we created that view with that restriction now. So therefore, this should not be allowed. This should not be allowed. Rather, we should get an error saying this is not valid. Right? You can see check option fail because this fail your check option. You can still do your update to salaries and so on, but not doing updates which take your records out of your view. That is what check options is guarding. Okay. Right. How to drop a view? Drop view, your view name. That's it. Any questions? That's it with views. Any questions about views? Right. If you don't have any big questions, we will move on to the security part. Of course, views are also part of the security, but we just took it separate. Okay. Right. Security. So when it comes to securing your applications, you need to secure at different levels. You need to secure your hardware, software also operating system level, application level, right? And also you need to secure your database, right? Because sometimes there can be security issues that take your data, okay? Take your data by hackers and so on. So therefore, we need to restrict access to the database. So far, we have been using the admin user, which is pretty bad because using admin user, we do all the things, right? Root. But in reality, we create separate users and give access to only for those databases. And not only for the databases, we can say, okay, in this database, you can only work with this table or these set of tables. Not only that, we can say, okay, you can only do select statements, this particular user, not update or delete. So that kind of restrictions also we can say. Or we can say you can do manipulation, but you can't create tables, drop tables, right? So that is for administrative purposes. Okay. And also by creating a user, we do authentication. Only authenticated users can access. Then authorization. What kind of things you can do? Maybe you can access this table and that, but not is it. Maybe you can do select, but not update and delete and insert. Okay. So authentication, authorization. Okay. Right. So therefore, authentication, the first thing is you need to create users. Create users and drop users. So then authorization, you give access to specific artifacts. That is authorization. Okay. So how to create a user? Right. How to create a user? This is how you create a user uh, in MySQL. Okay. So let's call this Aurora 2 because I think we have already created Aurora 1. Or let's call this Somerset. Create user, Somerset at localhost. Or this must be IP address of that server where you have the database. Identified by, this is your password. This is your password. Right? Create user, username, identified by, that is your password, which later users can change. Right? So let's create a user. Okay. So this user can be given multiple access to multiple databases also. Or you need to restrict that. Okay. Create user Somerset at localhost, identified by null. Done. Right? So now these user details are not going to your tables because your table doesn't have any user details. Okay. These user table details go into there's a table called MySQL. Right? MySQL. It has a table or view called user. These details go into that table. You can see this is a system database. When you install your MySQL, already this database is there. And it has some tables, right? You can see that it has some tables which are for MySQL stars, so many tables actually. Then there's one view called user. This is something the MySQL installation has created. And when you insert a user, it's going to this view, and also it goes to some of these tables. I can't remember exactly which table. මොකක් හරි මේ table එකක් ඇතුළට තමයි යන්නේ. මොකද view එකට එන්නේ table එකෙන්නේ. But I can't remember exactly what is the table, but it's in the user view. And you can see this just I created Somerset, and password has been encrypted. But password when decrypted, it will be null. Okay. This is a root user. This is a root user. With blank password. And some other users are already created. Is it clear? Right. At any time, you can delete user as well. Okay. Right. So that is called authentication. Creating user account and dropping user account. Okay. So how to drop? Drop user username. Okay. Right. Now authorization. So authorization can be done in two different ways. What is known as user-based authorization and role-based authorization. In user-based authorization, user-based, so these are the resources like different tables, views, and so on. Like different tables and so on. So these are your different users. These are resources. User 1, user 2, user 3. Say resource 1, it can be table or views. So users are assigned privilege. So this user can access this table and this table. This user can access this and this. Maybe this user can access this and this, or all three. So this is called user-based authorization. User-based authorization. So whenever new user is created, you need to give access to set of resources, required resources. Maybe you don't want to give access to this. So this is easy approach, but it needs a lot of work, because whenever user is created, you need to manually assign access. This is called user-based privilege. Second approach is much more sophisticated or easier to use, more maintainable and more practical. In that second approach, we have again users. And the resources are also there, like tables and views. Then there's an intermediary concept called roles. Say user 1, user 2, user 3, user 4, resource 1, resource 2, resource 3, resource 4. So then we have concept called role. Unfortunately, resources also are, role is also are. Therefore, I will use simple R. Say this is role 1, role 2, role 3. Maybe this is manager. This is operator, cashier. Maybe admin. Okay. So then we can assign different users, can be assigned different roles. Maybe this user has only this role. This user has only this role. Maybe this user has both these roles. User can have multiple roles. And maybe this user has only this role. So maybe this particular user is both engineer and manager. That is engineer role, manager role. But this user is only engineer, not a manager. Maybe this user is just operator, cashier. Is it clear? If it is not clear, just let me know, okay? So then, rather than giving access to users are given access to the resources, now we give access to the resources, access of the resources are given to the roles. Say role 1 can access these two. Role 2 can access only this. Role 3 can access this. Oh, now then my user 1 have access to this because it has role 1 and to this. My user 3 because user 3 has role 1, user 3 can access these two, and also user 3 has role 2, therefore user 3 can access this resource source. So that is called role-based access control or role-based authorization. This is more practical approach. When you are doing a final year project, definitely you must go for role-based authorization. Still, I have seen that final year project students in their final year, they go for user-based authorization, which is pretty bad. If they see it, sometimes they ask you to explain how the authentication authorization is done in the Viva. If they see it, they will be really right. You will be penalized, saying why do you go for user-based authorization for your final year project? Okay, is it clear? Right, but here we are more coding session. We are more interested in user base because role based authorization need additional SQL, right? But we will look at the SQL, but practically I'm going to do only user based authorization session. After doing the practical session, we'll get back to theory. Right, so now I have created the user call Somerset. Now I'm going to give that user access to certain resources without roles. That is user based authorization, okay? Right. I will be using the command line because that is better. CMD, you can better understand also now. Right. So I'm connecting to MySQL. You know how to connect to MySQL. MySQL minus U root. That is I access as root user. Minus U space root. Right. I will take another command line. That is a different session. Remember, I created the user called Somerset. MySQL minus U space Somerset. You don't need to say localhost because you are connecting from the same machine. And minus P password. Minus P without space, you need to type the password. Minus U with space username. Minus P without space, your password. The password I added was Nalaka. Okay. And no semicolon because this is DOS prompt. Okay. Right. So this is Nalaka user. Uh, this is Nalaka user. And this is admin user. Okay. Now let's see what are the databases. Show databases. It only shows information schema, but actually we have more databases, right? Say this is admin user, root user. Show databases. But my Somerset user can't see any database other than this information scheme because we just created the user. By default, user has no access. No access. Right now, we are going to give some access to our user called Somerset. Okay. Right. This is how you give it. Grant. Right. Select on this table to this particular user. That is okay. I will explain that. Now this must be done by using the admin user because admin user can give privileges to other users, or you must give that privilege to that particular user, and then that user can do that also. Of course, this user is very innocent user. That user can't even see databases. Now we are going to give a little bit of privileges, but not role based, user based. So this means grant. Grant means giving access to select on semester 225 database its employee table. So that means semester 225 database employee table selects privilege is given to our user is Somerset. Somerset at local loss. Okay. Just a tiny privilege only. Why is that? Grant wrong checksum. Somerset, is it spelling correct? Summerset, correct, right? Grant select on S225.employee to Somerset at local host. Okay, so let's see whether we can see the user first. So we can check whether the user is there by query on this. Use MySQL because that is a table database. Right, use MySQL and select. Yes, Somerset is there, right? Okay, so shall we go into the database and do this? Use S225. And now let's see whether we can do it. Say Somerset. We need to go into the database, right? So I selected that database first using use and then gave the access, right? So this must be slightly changed. Yes, you can see you need to go to the database and then do it. Okay. Now look at the other user. Now earlier this is Somerset user. When I type show database, it didn't even show anything. Now let's see. Show databases. Now we can see S225 because we have given access to one of the table in that database. Of course, when you are given access to a table, that means you have access to the database. Now let's see show tables. Tables. Show. Right now you need to connect to the database because now you can see the database. Right. Use S225. Right. Use S225. Right. Now show tables. It can see only employee. Actually, there are two tables. Right. But for admin, if I say show tables, we have not only the tables, we have the view also. But this guy is given only select access to the employee table. So therefore, this guy can only see employee table. Now this guy can write select queries on employee. Say select all from employee. But this guy can't write select all from department because department access is not given. But it says, there's nothing called department for you. Security. And not only that, you can do select on employee, but you can't do insert, update, delete. If you try to delete, right? Say delete from employee. Say where ID equal 4. Right? It says, no, you can't delete because you are given only select privilege. That is how user-based authorization works. Is it clear? But if I grant delete, Yes, then we should be able to do that. But that access must be given by some user which has the privilege to do that. That is why I'm using the root user. Okay. At any time you can revoke. Revoke. So now let's revoke the select privilege. So revoke select on. If you want to give it to all the databases, you can do like that. Okay? All the databases, all the tables. But only from employee table. From the earlier two now from because you are revoking Somerset at localhost. Now we revoke. Right? Revoke. Select privilege. Now, if I try to execute select all from employee, remember earlier we managed to do that. Now it says you don't have access because it has been revoked. Okay, so that is how the security is done. Right, now I will get back to right theory part. Now you know how to do that, right? Now you have the idea. Right, so we can grant privileges, we can revoke privileges to users and from users. And the privilege can be select privilege, insert privilege, update privilege, delete privilege of a specific table or all the table in that database or all the tables in all the databases and so on. Then you need to use star. Okay, so this is how you grant update this particular field. That means only this particular field you can update on employee table. Two, if you have multiple users, you can use multiple users, comma separated. That means now user 2 and user 3, of course, the user 2 and user 3 must have been already created. They can write update statement on employee table, but they can only update designation. They can't update salary and so on. Okay. What is this? Grant, select, and insert on employee table to user 2. That means now user 2 can write, select, and insert on employee table. Right. This is revoking. Revoke select privilege on employee table from user 2. Revoke update of designation on employee table from user 2. Okay. Right. So there's a concept called propagation of privileges. Propagation of privileges. What is mean by that? So that means now when I create, say I am in the head office, I am the root, I am the big admin. I am the system administrator of says particular business organization. So I am the big root admin. Maybe we have some branches and they also have their technical staff. Right? So there's a table called employee. I want to give access to employee table, that is maybe select, update, delete for some particular admin user here or manage user here, manager 1, manager 2, manager 3. Okay, so then I can say grant select on employee department to say manage user. Then only that user can do those. That user, when using that username, when password login, that user can now write select statement on employee and department. But if I have now, if there's another user in that department, again I need to write that, give that privilege. So rather, I can give this privilege to this particular user as well as now that user can give it to some other user. Right? So that means I give that access to that branch admin. Branch admin should be able to give it to someone else in that branch. So if you want to do like that, you need to give your command, say grant select on employee command department to be with grant option. That means we are not only giving this access to this particular user. Now this user also can give that access to some other user. That is called with grant option. That means it's like devolution of power. Right? Not only you can do this, you can give this privilege to others. So we do this kind of things only to managers, admins, and so on. Okay. So now you can see B also can write this kind of a statement and give the same privilege to another user. Okay. Is it clear? So that can be done if your grant statement has with grant option part. Okay. So likewise, it can go as a hierarchy. Sometimes it can be a sort of a graph also. Say Prasad get some privileges from Sarath. Sarath has given some privilege and Kapila has given some other privilege. Now Prasad has both the privileges. Okay. And if you got it with grant option, now Prasad can give all your privilege to Pasan also. But Prasad, okay, because that is if you have got it with grant. Maybe some privileges you got only the privilege, some privileges you got with grant options. So those with grant option privileges you can give it to Pasan also, but not the other privileges. Other privileges only you can use. Okay, right. So as I told you, in role-based authorization, you can create roles. Just like users, you can create roles. That you can check in your MySQL, but I'm not going to do it because we are running out of time. So it's just like anything, you can just say create role, right? So then you can even give a role, password to the role also. So what is the meaning of password to the role? Of course, no one is going to log in as a role, right? Only the users are going to be role. If you give password to the role, when you assign that role to another user, you need to enter that password. Okay, you need to give that password. That is security. Okay, so therefore, no one is going. No point using login using a role. Always users must be login. But then when you give that role to another user, you need to give that password because your role has a password. Okay. So then you give privilege to role rather than users. Say grant, select, insert, update, delete on product table to this particular role. Right? It can be even create user privilege, create table privilege, drop table privilege, not only select, insert, update, delete, right? Privilege can be even create table, alter table, drop table, truncate table. Okay. And not only that, you can give some roles to another role. That means there are two roles called product manager and HR manager. So those two roles are assigned to another role called overall manager. So that means overall, if some user has the overall manager role, that user has all the privileges of HR manager and product manager. Okay. Now we can assign the roles to users because ultimately it is the users that log in. Now we have created roles and assign some privileges, and also roles can be assigned other roles. Now when we after creating users, now we are going to assign roles to the users. Say grant overall manager role to user one, and with admin options also we have given. Okay. So then this user one has all the privileges given to overall manager. overall manager. That means all the privileges given to product manager and HR manager roles. So that means these privileges are there, these privileges are there. You can create users, you can do select, insert, update, delete on product table as well. Right? And at any time, you can revoke roles from users. Revoke. Right? For example, now that particular user is not operator, rather manager. Now you can revoke the operator role and assign or grant manager role. Okay. And also at any time you can drop roles. Of course, when you drop role, make sure no user is assigned that role, because otherwise you can't drop role. Just like drop table, drop user, you can drop roles. Okay. You can assign your default role also. So you have multiple roles, but only one role can be assigned as a default role. That is just for management things. Okay. And that's it. Is it clear? Now your syllabus is over. Your syllabus is fully over. Database side, not other topics. Let me give that file to you so that otherwise I will forget it. SQL, because it has almost all the code we discuss in throughout this database sessions. Okay. Codes. Now that is the end of the coding, right? SEM 25, SEM 2 database. Right, MongoDB commands also, I will give both, okay? MongoDB commands, of course, we did it for the web part last week. Semester 2. Right, so we'll take a small break. After the break, we'll do, I think we have two more topics to finish in software engineering. Then you can concentrate on password for that also. So now it's 11:23. We'll take only 5 minutes break. We'll start at 10 minutes break, 11:35. And next week, I will try to add one more extra session to do past papers on maybe database or maybe communication skills or something, so that we can finish quickly. It will be either Wednesday or Thursday, okay? Or Friday. Right, we'll
So
start. Yes.
So what are the resources for learning more about data security and views?
Data.
Data security and views.
I can't say exactly what. So you need to do a Google search, right? I can't say exactly because it depends on the length you want to learn, right? Maybe you can use ChatGPT and so on. Okay. And also your reference book is also there. Right? I can't say exactly because these are very depends on the databases and so on. Okay. And some textbooks are very theoretical. Okay. Best
Okay.
thing is go to YouTube, do a Google search, and also talk to ChatGPT. ChatGPT can really help, especially when you are doing practical things. Just uh, if you get an error, just copy paste the screenshot. Then ChatGPT will
Okay,
say,
sir.
okay, right. We'll start at 11:30. Right, software testing. By the way, you have subject called software quality assurance in my final year also. One full subject was SQA. Okay, because testing is super important aspect in software development. Right. So how to ensure the overall quality of your software? First of all, you need to plan and manage quality assurance. So that is why we need QA engineers, quality assurance lead, QA lead, right, under project manager, right. And also, it's a responsibility of the entire team. It's not just the responsibility of the QA members. Every developer, every software engineer's responsibility is also for make sure the quality assurance is done. Okay, high quality product is developed, right? So therefore, to ensure proper QA, we need to make sure that we have the QA process, part of the management, which include testing, and also make sure you have very high quality developed team members. So basically, when you have high quality development team members, so they always make sure that your software quality is very high. That means, first of all, they make sure that they write bug-free code as much as possible. At the same time, they will make sure that your software is properly tested. Okay, right. That is the idea. So ultimately, get a high quality product, high quality software. Right. So when it comes to software quality assurance, so there are two main tasks: validation and verification. Right. So what is verification? Verification comes first, then comes validation. So validation is testing, right? Validation is testing. So verification means that is something when we do our development, we make sure that we come up with high quality software. How to do that? So that includes having quality standards, right? And review whether you maintain the quality standards. So that is where we need very high quality conscious team members, and also they follow the quality process, right? Like code reviews and so on. So that is called what? Software verification. So the what we try to answer is, are we building the product right? අපි හරි විදියට product එක හදනවද? හරි විදියට product එක හැදුවොත් හරි product එක හැදෙයි. Right? හරි විදියට හදනවද? Right? Are we building the product right? So this is quality assurance step, not quality control, quality assurance. This assure the quality. Okay. Which includes reviews like design reviews, lead reviews, peer reviews, inspections, walkthroughs, and some static analysis using some tools. Okay. So the advantage is when you do proper verification, that means you do it in a proper way, there's a higher chance your product is high quality, having less issues. And ideally, of course, that is hypothetical. If you do this properly, you don't need to validate because you know that it's always perfect. But we are not perfect, right? That is why we need validation also. Okay. But the more you focus on verification, the lesser the burden for validation. Okay. Lesser the burden for validation. For example, one of the software development company I worked about more than 15 years ago, right? That is the best place I worked also. No QA engineer was there. No QA engineer. Only software engineers and project managers. Right? Only software engineers and project managers, no QA engineers. So that means 100% the responsibility of quality is given to the software engineers. That means a lot of emphasis on verification. It doesn't mean that validation is not there, but validation is also done by software engineers, not by QA engineers. But these days, a lot of QA engineers are there because part of that responsibility is given to QA engineers Anyway, that it depends on the way you develop your software. Okay. So therefore, if you concentrate on good software verification, so that means you always think about the broad aspects of quality. So it results in less issues to detect at the validation or testing. It improves the overall design and quality of the product. Right? And also it will give you better chance of overall non-functional requirements like performance, user friendliness, because you are developing a quality product, maintainability. Right. So then validation is checking whether are we building the right product. Earlier, are we building the product right? Now, are we building the right product? So that you need to validate, test, right? Test and double check, because we may make mistakes, we may miss certain things, right? So this is done by developers, testers, end users, and so on. Again, and it can be done at various stages. Right. So software testing is basically validation. Validate that functionalities are implemented properly and identify bugs and issues and fix those without delay so that those issues are not going to your production servers. So again, the result is better quality product because both verification and validation contribute to quality. Better customer satisfaction, better product, or reduce the issues in the product and reduce the maintenance cost, because if you could release a bug-free product, nothing much to maintain, right? Right. So therefore, remember testing is part of the quality assurance, not the quality assurance, right? Just part of it. Don't just think that testing will solve all my problems. Actually, if you have not done your other things well, you will have to spend hell a lot of time doing testing because you have not done your development properly. And of course, make sure you allocate time and resource for testing. Some project managers tend not to allocate enough time for testing. They think this is waste of time. No, this is not waste of time. It's a must activity. And make sure you do different type of testing at different stages. And make sure the responsibility of testing is given to the entire team, not just a few of those. For example, unit testing must be mostly done by developers, not by QA engineers. And also a bit of system testing must be done by developers before giving that task to the software engineer, QA engineers. Right. So some more points to remember. Exhaustive testing is impossible in software unless it is hello world application. So that is why you must not rely 100% on testing for bugs. That is why verification is important. That is why you need to find the high quality software engineers. Otherwise, if you don't find high quality software engineers, you need to hire hundreds of QA engineers. But if you hire high quality software engineer, you can cut down some of the QA engineers, because high quality software engineers make sure that they develop products, bug free products. That is why software engineering field salaries are there's a big variance, right? So some guys get, I mean, the starting salary, right? Not with experience. Some guys get even 300,000, 400,000 starting salary. Starting salary, okay? Your first salary, 300,000, 400,000. At the same time, some people get only about 100,000 and some people get only about 50,000. And some people, they don't get the jobs. Every interview, they are rejected. While some people are offered 400,000. Some people are offered 100,000. Some people are offered 50,000. And some people, they keep going to the interviews, they don't get the job. So why? It's their quality. quality, attitude. Okay. Because if you hire this guy, right, this guy will do more harm to the product than good. Maybe a lot of bugs are introduced to the code. So then they will say, no, you don't do code. We will do the coding. Because when you do coding, you introduce hundreds of bugs. Okay. So that is why they don't get the jobs. That is why you need to be a very high quality conscious person. Right. We can categorize testing into two: glass box or white box testing versus black box testing. So glass box means doing the testing with the awareness of the internal structure. So this can be usually done by developers because developers has very good idea about the structure from class diagram, ER diagram, everything. So they mostly do the white box or the glass box testing. Usually the unit testing, interface testing, integration testings are glass box testing. Knowing how the unit is developed, you test it. Knowing how the interfaces are developed, you test it. Okay. So usually initial type of testings are white box or glass box. Latter part testings are more and more black box. So black box testing means without thinking, considering the implementation and design, you just test system as a whole. For correct input, are we getting correct output? So this is how we do system testing, user acceptance testing, and so on. And mostly, initially these testing are done by development team, developers, but later mostly done by QA engineers. And finally, end users will do the testing. Okay. So testing can be done in development stage, obviously, like unit testing. Releasing stages like system testing before releasing, and also the user testing before accepting the product. So these are different type of testings, not categories, right? All these testings are either white box or black box. Unit testing, interface testing, integration testing, system testing, alpha and beta testing, user acceptance testing, and some other testings like usability testing, performance testing, stress testing, regression testing, or smoke testing. Right. So let's take one by one very quickly. So unit testing means you test your units, your modules, say your payment functionality, your order functionality. It can be done at method level, class level, or module level. And these are obviously glass box testing done by developers. That is where you write unit test. There are unit test frameworks like JUnit, okay, test NG. You will learn about those things in semester 6, quality assurance, how to write unit test code. What are the frameworks available? Depending on your technology. So we test individual units. That unit can be method, class, or some particular functionality. These are all glass box testing and done by developers during development. And we can automate using frameworks like JUnit, TestNG, and so on. So this is an example of a JUnit test. Don't worry, they don't ask you to write code, right? You have MCQs. But these kind of questions are there in semester 6, right? Because you have the essay paper. Right? Don't worry about these things, right? Maybe I can generate a class, say IntelliJ. Yeah, you need to configure that, okay? Anyway, let's see whether we can, without configure, we can write a JUnit or TestNG test. So these are some, this is a semester for 6 students. These are some automation of testing, web testing and so on, like Selenium and so on. Okay. Uh, right. So let's try to write a simple test. This is normally IntelliJ. Okay. New project. Maybe Maven project. දැන් chat GPT තියෙනවද ඔයාලට තනියෙන් ඕන දේ ඉගෙන ගන්න පුළුවන් හරි. Right. I think Maven add unit testing. Let's see. නෑ add කරලා නෑ unit test එක. chat GPT ටික ලියලා දාමු. chat GPT නම් බය වෙන්න එපා හොඳේ. How to use test ng in IntelliJ Maven project. Say hello world example. මට කෝඩ් ටික ජෙනරේට් කරගන්න ඕනේ නැත්තම් මට කෝඩ් මතක තියාගෙන ඉන්නේ නැහැ නේ මම ප්‍රොජෙක්ට් එකක් හැදුවා මේවන් ප්‍රොජෙක්ට් එකක් test ng දාන්න ඕන. This is a unit I'm downloading jar file for the unit test. Okay, so there's something called form xml that we need to add this. Then it will download this particular jar file. Refresh. So මෙතනට එයි දැන් හරි external dependencies කියලා. This is how the soft unit testing is practically done. Okay. Test ng කියලා ඇවිල්ලා තියෙනවද බලන්න. නෑ නේද? Maybe we need to build that.
So what is Maven project?
Build project.
What is the meaning of Maven project?
Right, don't worry about that. I'm just showing you what to do. This is not related to your exams, okay? Otherwise you don't know what is my unit test case, okay? This is nothing for your exams, just I'm explaining what is unit testing is, okay? Right, so I think it has create a class, no? Right, so this is a class, and now you can create your test case. Okay, so let's create this class, hello world. මම මේකම code paste කරලා මට ඉක්මනට කරන්න පුළුවන් අද. ඔබ දන්නවනේ unit test එකක් කියන්නේ මොකද්ද කියලා. Java class hello world. This is the code. I am getting errors. I am getting error. But it says return string, right? මට වෙන ID එක පිස්සු කරනවා කොයි. Local variable එකක් දාන්න බෑ මොකටද? Still the error is there, right? Okay, so we'll rename this one for new Java class. Lower class no errors. මෙන්න මේක එකක් එන්නේ. මේ method එක copy කරන්න කියලා. String කියලා දාන්න දෙන්නේ. String variable declare කරන්න දෙන්නේ නැත්තේ. I think some conflict with some other packages, okay? Otherwise, I should not get any issue for this, right? Anyway. Yeah, string class එක මොකක් හරි conflict වෙලා තියෙන වෙන class එකක් එක්ක. හරි class එකක් පෙන්නනවා. It has been conflicted with some other thing. Okay. Is it coming from my mail? No, it can't be. String කියලා මගේ අතින් class එකක් හැදලා තියලා කොහේ හරි. නෑනේ. String. X type to string. ඉතින් string තමයි තියෙන්නේ. Okay, forget about that. Otherwise, I need to figure out what is this error. It's a stupid error, right? It says string cannot be resolved. Okay. Right. So maybe I can explain it in the next class. Otherwise, we'll be spending a lot of time. Right. So once you write your class and method, you can write your unit test method like this. That is what I try to do, but I'm getting a stupid error saying string is not resolved. Okay. So then you create object of this class and call the method, and check whether we get the correct result. We get the correct result. Say if you're adding two numbers, of course, for adding two numbers, you don't need unit test, right? It can be big calculations and so on. But we can check whether we are getting the expected result. Say we expected 10, but you got 5. So then there's error. Or the unit test is failed. Okay? Unit test is failed. But when we expect 10, if you get 10, unit test is passed. So then we can automate it and run it and see how many unit tests pass, how many unit tests fail. And sometimes what happens is when you do some coding changes, some of the unit tests start failing. So that means while we are implementing some functionality, we have break some other functionality. So that is why we want. So then when we run the build, all of a sudden you will say that some unit tests are failing. So that developers can go and see why. Maybe while you develop some other logic, you have break some other existing logic. So that means very quickly we can identify the issues. So that is the beauty of unit testing. The idea of unit testing is make sure you detect errors early. Especially when you change something, you may introduce new bugs. Maybe you try to fix one bug, but rather you introduce another bug. Maybe that bug is fixed, but you have introduced two more bugs. So those things can be, first of all, you need to be very disciplined software developer, but at the same time, if you have unit tests, plenty of unit tests, those unit tests will fail and say, okay, there's something break. Okay, something you have broken. Okay, that is the idea behind unit testing. So unit testing is another class, test classes we need to write. Okay, right. And also we can integrate it to your IDs like your IntelliJ and so on. Okay. So remember in agile development, we discussed something called test-driven programming. In test-driven programming, we first write the unit test and then write the code. Of course, when you first write the unit test and not the code is available, the test fail, that is fine. But when your development is done, all your unit tests must be passing. Okay, that is the idea of test-driven. So the conventional approach is you first write the code and then test. In this approach, you first write the test, especially unit test, and then write the code. So when you first write the test, you have very good idea about the functionality, expectation. Right? In a way, it's very psychologically also it promotes you to write quality code because you know that if you don't write your quality code, your tests are going to be failed anyway. Especially that approach we can use in unit testing. And this is in agile development, we call it test-driven programming. Okay. Anyway, you have a subject called agile development in semester 4. There you will further understand what is this test-driven programming. Okay. In agile development. Right. So that is unit testing. It's a white box testing. Another white box testing is interface testing. When we develop our modules, we want to check whether our modules integrate with other modules. So that is where we do interface testing. We test the interface. Can we do proper integration? So these are important when you develop software as a set of components like web services, enterprise Java beans. You will learn about component-based software development in semester 4 because you have a subject called enterprise software development. Okay. Enterprise application development. So there you will learn what are those components, web service components, EJB components, and those components we need to test whether one component can be integrated with the other. That is where we do interface testing. It's another glass box testing done by software developers. Okay. Then integration testing. So slightly different. Interface testing is a glass box testing. Integration testing is now we integrate modules and see whether those are getting integrated. Okay, so this is done before system testing. And integration testings are very much related to interface testing, but interface testing is more technical and white box. Integration testing is more functional, black box type. Okay. Because sometimes the unit test pass, but integration test fail. That means test units are not properly integrated. වෙන වෙනම ගාන්ටි හරියට හදලා දෙනවා නමුත් මේවා හරියට ඉන්ටිග්‍රේට් වෙලා නැහැ. කනෙක්ට් වෙලා නැහැ. Okay. And And then we do the system testing, which is pretty much testing your system as a whole. Initially done by developers, then the responsibilities hand over to the QA engineers. Test the system as a whole. This is black box testing. For some extent, QA engineers can use system automation like tools like Selenium, but majority of this testing must be done manually. Okay. Right. It's a very formal approach, right? You write your test cases, prepare your test data, then do your testing and record the test result. If test case is failed, you need to lodge a bug, because test case fail means functionality is not working. So then you need to raise a bug. There are bug tracking systems in software development companies, and the bug is raised by the QA engineer and assigned to the development team. Then the tech lead will look at the bug and assign it to the relevant developer, and the developer need to open the bug and see the steps and recreate the bug. And if it is there, developer need to fix it and again test it and close the bug, so that in the next release, again the QA engineers will retest that. And if it is no longer there, they will close that bug. Otherwise, they will reopen the bug, saying this bug is still there. Bug එක reopen වෙනවා කියන්නේ developer ගේ නේද? සායම ඉවරයි. හරි. bug එක reopen වෙනවා කියන්නේ developers ලා responsible. හරි. ඒක ඔක්කොම track වෙනවා reports වල. ඒ developers ගේ module එකේ bugs කීයක් තියෙනවද? ඒවා severe 1 bugs කොච්චරද? severe 2 bugs කොච්චරද? bugs reopen වෙනවද ඒ developer ගේ? So that means not a very disciplined software developer. දැන් වාට තේරෙනවද සමහර ලක්ෂ 5 10 වෙච්ච සමහරු කොහොමද ලක්ෂය ඉන්නේ කියලා? ඒ ලක්ෂය ඉන්නේ අර නේද? කෝඩ් ලයින් 100ක් ලියුවොත් බග්ස් 500ක් දාන්න ගන්නවා. හරි. සමහරු එහෙම නැහැ. කෝඩ් ලයින් 1000ක් ලියුවට එයාගේ මොඩියුල් එකේ බග්ස් එන්නේ 1යි 2යි. quality software engineers ලා. හරි. quality software engineers ලා. වැඩේ තත්කාල කරලා හරියට කළා. එයාට තේරෙනවද මේ සැලරි ඉන්ක්‍රිමන්ට් වෙනස් කරයි කියලා? දැන් මම හැමතිස්සෙම කියනවා නේද? සාමාන්‍ය software engineer කෙනෙක් අවුරුදු 5ක් ජොබ් එක කරනකොට එයාගේ සැලරි එක යන්න ඕන ලක්ෂ 8කටවත්. හොඳ software engineer කෙනෙක්. ලක්ෂ 8කටවත් යනවා. අඩුම ගානේ 5 පන්නන්න. හැබැයි ඔය අතර ඉන්නවා අවුරුදු 5ක් කලින් අවුරුදු මාස 3කින් ගෙදර එන අය කට්ටියක් ඉන්නවා ඉන්න බෑ කියලා. දැන් සමහරව එහෙම නෑ. සමහරව අමාරුවෙන් තාම 60000යි තාම 70000යි. ලොකු වැඩ දෙන්නේ නැහැ. ඒගොල්ලන්ට දෙන්නේ පොඩි පොඩි වැඩ කරන්න දීදී තියා ගන්නවා. ඉතින් ඔය 60000 70000ක් දී. Okay. Right. So therefore, the system testing is mainly done by QA engineers. QA engineers. So QA engineers need to document these test cases and so on. ඒතකොට කාට කියන්නද QA job හම්බ වෙනවද? QA jobs හම්බ වෙන්නේ නැහැ සමහරවිට. QA jobs කරන්න හොඳට communicate කරන්න පුළුවන් ඉන්න බෑ. document කරගන්න පුළුවන් ඉන්න බෑ. සමහරවිට එහෙමත් බෑනේ. ඉංග්‍රීසිත් බෑනේ. ඊළඟ test cases ගැන ඔළුවේ තියෙන idea එකක් නේද? Of course, QA engineers, they don't get big salaries, but they get reasonably good salary. කැතනතු ජීවත් වෙන්න පුළුවන් salary එකක් හම්බ වෙනවා. හරි ලක්ෂ 2ක්වත් හම්බ වෙනවා ඒගොල්ලන්ට. අරගොල්ලන්ට 6ක් 5ක් හම්බ වෙනවා. ඒ සමහරවිට QA කරගන්නත් තේරෙන්නේ නැහැ. test case ඇලියා ගන්න තේරෙන්නේ නැහැ. requirement එක තේරෙන්න බෑ. හරි. Right. So you need to write your test cases for system testing. Prepare the test data. Sometimes you need to do some test automations using tools, and then you execute the test. And is there any issue, you need to report the bug. Okay, report the bug. ඔගොල්ලෝ නිකම්ට කියලා බලන්න QA engineer කෙනෙක්ගේ මොනවද බලාපොරොත්තු වෙන expectations කියලා. software engineer කෙනෙක්ගේ. මම මේ පාර අද තියනවාද කියලා මොන හරි job vacancies. දැන් ඔයගොල්ලන් ටික ටික jobs ගැනත් හිතන්න. නිකන් ඔහේ ඉන්න එපා girl වලට. මොනවා හරි මම කියන්නේ හැමෝටම IT කරන්න කියලා. මිනිස්සෙක් වුණාම ගෙදරට බරක් වෙන්න එපා. බලමු QA පැත්ත. එන්නේ software quality assurance engineer. දැන් මෙහෙම නිකන් දෙන්නේ නැහැ මේ jobs හරි. Yeah, if you are persuasive, energetic, පේනවද? ඇඟේ ශක්තියනේ positive කෙනෙක්ද? Ready to go to the extra mile. Come and join us. ඔයා වැඩේ වෙනකම් බලන් ඉන්නද වැඩ කරන කෙනෙක්ද? ඇඟේ උනන්දුව තියෙන කෙනෙක්ද? අනිත් මිනිස්සුන්ට වැඩිය ඉස්සරහට හිතන කෙනෙක්ද? එහෙනම් ඔයා එන්න අපිත් එක්ක වැඩ කරන්න. Quality assurance engineers. Okay. Degree in computer science or information industry certification, 2 to 3 years of technology specific experience, planning, conducting the process of functional testing, analyze product requirements, document, investigate, and blah blah blah, communicate test execution results, like the test execution results communicate කරනවා. Escalate issues to the software development team, write test cases and maintain documentation. ඔතන අපි කිව්වේ මෙච්චරනේ. But this is not software development, right? This is not software development, but this is also another part in your career. Okay. Right. So when you test, you need to test different scenarios. මතකද අර උදේ maths කරද්දී අර සමහර logic question කරද්දී මම කතා කරා positive integers වලට වැඩද negative integers වලට වැඩද නේද? ඊට පස්සේ මම කිව්වා අපි මේක බලන්න ඕනේ fractions වලට භාග සංඛ්‍යා වලට වැඩද කියලා positive negative. ඒ කොහොමද එහෙම අර එහෙම එන්නේ ඔළුවට? So that is testing experience. ටෙස්ට් කරනකොට අපි එක එක සිනාරියෝස් ටෙස්ට් කරනවා. ඒ සිනාරියෝ එක හරියට අපිට අනිත් එකෙන් වෙන් කර ගන්නවා. නැත්නම් අපිට සිනාරියෝස් මග ඇරෙනවා. සිනාරියෝස් මග ඇරලා අපි ටෙස්ට් පාස් කියලා යවනවා අන්තිම ටෙස්ට් ෆේල්. මොකද ප්‍රොඩක්ෂන් එකේ ඒ සිනාරියෝස් එන්න පුළුවන්. So that is why you need to prepare your test data. You can partition into different scenarios, different ranges and so on. Because they behave differently. And from that scenario, you can do only one test. That is fine. But you need not omit. If you can't find the scenarios, you waste your time buying too many testing. Or else you skip some important scenarios. Right? So that is very important. So that is why you can't just become a QA engineer, right? QA engineer ඔළුවක් තියෙනවා. Scenarios ටික අඳුර ගන්න. Communication skills තියෙනවා. Test case ලියන්න. Development team එකත් එක්ක කතා බහ කරන්න. Reports දෙන්න management එකට. Right. So that is system testing. And another type of testing is alpha and beta testing. So these are when we are very, very much ready to release, but still not officially release. Maybe we want to get it tested by end users. Ask them to use it in informal level, not officially, and give us feedback. That is called alpha and beta testing. So initially we do alpha testing. Then when we are confident that it's fairly stable, we upgrade it to beta testing. Yeah. And then only we do our release, okay, official release. Okay. So alpha testing sometimes we conduct by internal staff also, but thinking like end users. But beta testing, because this nearly finished now, we are very confident, but still not officially released. So we can ask the end users to test it or use it in informal settings and give feedback. Right. Finally, the user acceptance testing, which is done by end users with the help of QA engineers, and they will either accept the product or reject the release. So if it is rejected with some reasons, we need to fix those issues because release is rejected by the end users. Okay, so those are pretty much black box testing. Okay, So then we have regression testing. So that is when we develop something, there's a possibility that you break something else. Right? You develop or maybe you fix one bug. While you fixing that bug, maybe you have created two more bugs. So that is why we need regression testing. So when we develop something, we can't just test that functionality. We need to do overall testing again, overall system testing to check the health of the system. That is called regression testing or the smoke testing. Okay, smoke testing. Okay, because sometimes when you develop something, you introduce more bugs, especially if you are not a disciplined, competent software engineer. Okay. And regression testing is very boring type of testing because you do these testings over and over. And that is where we try to as much as possible automate regression testing. And you will learn in final year how to automate regression testing, like tools like Selenium and so on. And also how to automate the build. Okay. Right. So the usability testing is testing for the user friendliness. You will learn about usability testing in great details in semester 3 because you have a subject called user experience design. So this is not checking the functionalities. This is checking how user friendly, how ease of use of the product. Okay? And we heavily get the help of the end users here. Then the performance testing. Right? Because no point doing a search and wait for 1 minute to get the results. No point waiting 5 minutes to generate a report. So we need performance testing. Load testing sometimes under heavy load, sometimes performance degrade. Right? Load testing. That means when the system is accessed by say 10,000 users at the same time, what is the performance level? So definitely for this kind of testing, we need tools because you can't find 10,000 users and testing. Rather, we can use tools. Okay. And the tool will apply the load according to our scenarios that we have recorded and give the results. Okay. Response times and so on. Then stress testing is testing under extreme situations like extremely low resources, extremely low bandwidth, right? And some things like that. Under unstable situations, can it survive without crash? Okay. Right. So make sure you go through the UCSC note as well. Okay. Right. So we have, I think, one more topic which we can do it in the next class and finish that subject. Okay. Yeah. Evolution, it's half an hour topic, but we'll do it in the next class because I have another class in the afternoon. Okay. Right. So I will try to arrange one more extra class next week, most probably Wednesday or Thursday or Friday. Okay. Probably, yeah, maybe Thursday. Right. We stop at this point, right? Thank you.